Hello guys, welcome back to Math Zone African Motives. Still working on our revisions for our O-level syllabus. We shall be focusing on the November 2010 question paper. That was the paper one. So to our 30 question paper, let us quickly see what we are given. Remember, read your information, understand your information properly. So on this one, we're supposed to answer all the questions, and whatever part that you're going to have, if working is needed for any questions, it must be shown in the space below that question, and omission of essential working will result in loss of marks. But this one is actually a lie because it's paper one. Paper one is just correct answer only. All right, so this applies in paper two. Paper one is just correct answer only, correct answer only. So you just making with the correct answer. Then the decimal answers which are not exact should be given correct to three significant figures unless stated otherwise. So it's all about when we are given the degree of accuracy that is not specific. Okay, so let us quickly rush through our questions. The first part was to evaluate the following numbers. So we are given this is 16.5 to the exponent of 3/2. So how are we going to simplify this part given 16.5? Everything being raised to the exponent of 3/2. Remember, from your laws of exponents, if you are given x to the exponent of a to the exponent of b, this is going to give us x to the exponent of ab. You multiply the exponents together. So in this case, we're supposed to multiply a half and a 16/2. So that was going to be a half multiplied to 3/2. So meaning to say at the end, we are going to obtain what? The numerator to the numerator. That's what, because here we can't reduce anything. So you can multiply the numerator to the numerator. So that was going to be 16. 1 times 3, which is 3 over the denominator to the denominator. That was going to give us a 4. But as we can see, this number that we have, it can be simplified since we are having an exponent, in this case, a power, an index power. So we are going to apply our laws. Remember that x, when being raised to the exponent of a over b, it is going to give us the bth root of x to the exponent of a, everything to the exponent of a. So in this case, we are referring to the 4 representing this b. So we are going to have the 4th root, in this case, of 16. Then everything is going to be raised to the exponent of what? To the exponent of 3. So the 4th root simply means the number that you're going to, it's going to multiply itself 4 times to give us a 16. So that is going to be a plus or minus 2, in this case, everything to the exponent of 3. So remember that if you are given an even number inside here, starting with the square root, the 4th root, the 6th root, your answer is going to carry a plus or minus as long as you are dealing with what? An even number. As long here there is an even number that is inside, we are going to apply the plus or minus on your answer. So in this case, we are going to have at the end plus or minus 2 to the exponent of 3. Remember, a negative to the exponent of 3 remains as a negative. So 2 to the exponent of 3, that is going to be 8. That is 2 times 2 times 2. 2 times 2, 4 times 2, which is going to give us 8 in this case. All right, so that was the first part of our question. The second part, which is on B, is 7 to the exponent of minus 1/4 multiplied to 7 to the exponent of 5/4 multiplied to 7. So this is raised to a certain power. Remember, if you are dealing with the bases that are the same, you're multiplying the bases that are the same, you add the powers. So you're going to add the exponents, in this case, under the same base. So meaning to say this was going to give us 7 to the power of minus 1/4 plus we add 5/4 in this case plus a 1. So remember that 1 can be written in terms of the base that we have, because if you check on our fraction here, we've got a common term, which is a 4. So we can also write this 1 as a fraction. So 1 as a fraction is simply going to give us 4/4. So this 1 that we see here can be written as 4/4. Why? So that we can simply add our powers together, or the exponents together. So we're simply going to add minus 1 plus 5 plus 4 in this case. So minus 1 plus 5, that was going to be a 4. 4 5 minus 1, that's a 4. Then plus this 4, it was going to give us 8. So we're simply adding everything all together. Minus 1 plus 5 plus 4, everything over 4. Since we are having the same denominator, we can add these numbers combined. So this was going to be 4 plus 4, which is 8 over 4. That was going to give us a 2. So we are going to remain with 7 to the power of 2. That's 7 times 7, which is 49. Do not mistaken, these are some of the minor errors that you might have. 7 times 2, you get 14. This is wrong. You are not supposed to multiply these. You multiply 7 times 7. So these are some of the minor errors that happen in exam. So we are supposed to avoid that. All right. The other part was 1 over 5 to the exponent of negative 2 in this case. How are we going to simplify 1 over 5 to the exponent of a negative? We can use two conditions here. The first one is that for you to remove a negative, it's an inverse. It simply means an inverse. So simply invert these numbers that are inside the bracket, invert the numbers. So we are going to obtain 5 over 1 to the exponent of 2. We have removed the negative. Just to remove the negative, invert these numbers. So meaning to say we are remaining with 5. 5 over 1 is same as 5. So this is 5 to the exponent of 2. 5 to the power of 2, that's 5 times 5. Which is going to give us what? Which is going to give us 25. Or you could have used the negative, just apply the stage by stage to say 1 over 5 to the exponent of minus 2. In order for us to remove this negative, we are going to write as 1 over. So it's going to be 1 over like this. That is to remove the negative. We remain with 1 over 5, everything being raised to the exponent of 2. So this is going to give us 1 over. The bracket is the one that is raised to the exponent of 2. So we are going to obtain 1 to the exponent of 2, which is 1. 5 to the exponent, which is to the power of 2, which is going to be 25 in this case. So on this part, you are dividing. This numerator is dividing to the 1 over 25. So meaning to say we are applying the same concept, 1 divided to 1 over 25. So you ask yourself, how am I going to remove this division so that I can simplify further? Remember, this is over 1. So we are going to have 1 over 1 times. The moment we introduce multiplication, we are inverting the second fraction. So this at the end is going to give us 25 over 1. So that is going to be a 25 in this case. 1 times 25, that's 25. 1 times 1, that's 1. So 25 over 1 and 25, just one and the same thing. So that is how we could have simplified this first part. All right, let us move on to the second question, which is question 2. Factorize completely. Take note. So that was actually 2 marks, 1 and 2 marks there, as you can see. So let us check the first part. We are asked to factorize x squared in this case. That is x squared plus 5x minus 6. Okay, I said on this condition, guys, when you are given the coefficient of x squared being a 1, you can apply direct factorization. Direct factorization, whereby you just ask yourself to say, since the coefficient of x squared is 1, meaning to say the first bracket is supposed to be x, the second bracket is supposed to be x. So you ask now to say, what are the factors of the constant, which is this term, which will add up to the middle term, and our middle number there, it's a 5. We need factors of negative 6. So there are so many factors of negative 6. You are concentrating on factors of what? Of negative 6. All right, sorry, let me just put this one so that we can list our factors together. So like I said here, we are going to consider the factors of what? Of negative 6. The factors of negative 6. What are the factors of negative 6? These are the ones that you are considering. We've got negative 6 and 1. We've got 6, change this to a negative. We've got negative 3 and 2. Change this to a negative, because 1 is supposed to be a negative. We've got 3 and negative 2. These are all factors of negative 6, but we want a condition whereby if you add these, so you start first by the factors. This is the most important part. You start by the factors. Which condition that when you add on this part, you are going to obtain a 5. So this is the condition that we have here. If we add 6 plus minus 1 is going to be 6 minus 1, which is a 5. So these are the numbers that we need, which is the 6 and the minus 1. So we are going to have here plus 6. Another one is minus 1, minus 1. That is the condition. only like that. Or you can apply the traditional method. The traditional method is the one that you are going back to say, all right, we are given x squared plus 5x minus 6. Remember our traditional method, we multiply the first term to the last term. This is 1x squared times minus 6, which is going to give us minus 6x squared. So you are going to find two factors which give us minus 6x squared. Take note, this time we are considering the x squared as it is. We are considering the whole part as it is. But these factors, when added, they must give us, now you are considering the middle term as it is, which is 5x. So these numbers are going to be the same. The same part that we did here is going to be the same, but now we are just considering to say there is x, there is x, there is x here, there is x here, there is x here, there is x here. That will be the condition. So which part, when we add, we are going to obtain 5x. Definitely, this is the same condition that we had on 6x and minus x. So these factors now, you substitute them or you replace them into the middle term. That is our traditional method, whereby we are going to say this is going to be equal to x squared. In place of 5x, you substitute those two terms now in the middle term, which is 6x and minus x. So this is going to be plus 6x minus 1x, which is same as minus x minus 6. So this is same as minus 1x. There's a minus 1 there, but it's just same as writing as what? As minus x. So by grouping now into 2, since we've got 4 terms, 1, 2, 3, 4, we are going to group into 2 so that we can factor out for the first 2 terms, what is common between these 2 terms? It's x. So we are going to divide x squared divided to x, which is x. 6x divided to x, as you can see, x and x will cancel with 6x over x. So this one will cancel, you remain with a plus 6. Now you're going to ask yourself, which part are you going to factor out so that you're going to obtain the same bracket as this one of x plus 6? So what are you going to factor out? You're going to factor out -1. So that negative and negative becomes a positive, negative and negative becomes a positive. So once we have the common bracket, which is the same bracket in this case, you factor out that bracket out. So we are going to factor x plus 6 out. The moment you factor at x plus 6, what are you remaining with here? You are remaining with x. Here you are remaining with -1. The terms that you are remaining with are going to be combined in one bracket, x and -1. So as you can see, we are obtaining the same answer that we just taken in the first place in a direct way. All right, that was the first part. We've got 1 mark for that. Then B, in this case, we're just given 2 terms. All you just need is to check what is common between these 2 terms. Start with the numbers first. So we are given 8m to the exponent of 3n minus 2m n to the exponent of 3. So let us check between the numbers. Do we have the highest common factor between 8 and 2? The highest common factor there, that's a 2. We move on to the m. We've got m to the exponent of 3 and m. How do you check the highest common factor when you are given exponents? You take the one that has got the smallest exponent. It must be common, having the smallest exponent. So that one is going to be m. Between this n and n to the exponent of 3, n is the one that has got the smallest exponent. So you're going to factor out n. That is your highest common factor. Whatever that you get here, you're going to divide this term divided to the what? To the first term. So meaning to say, if we divide 8 divided by 2, that is going to be 4. M to the exponent of 3, but there are 3 of them. So if we divide with 1, we are going to be left with the 2 of these m's. N and n, these 2 will cancel. We've got a -2 and 2 will cancel. M and m will cancel. N into n to the exponent of 3, we are going to remain with the 2 of them. We are factorized, but take note, it's factorizing completely. It's not an idea that whatever that you get here, if you multiply back, you must get this term as it was. No. The idea is to factorize completely. In this bracket, is it in its simplest form? We can see that this is a difference of 2 squares. We have got 4 as a perfect square, m squared is a perfect square, n squared is a perfect square. So how do we go about it? We are going to factorize this. Remember, for our difference of 2 squares, we are going to have 2 brackets. We find the square roots of these numbers, of these terms. The square root of 4, which is 2, the square root of m squared, which is m. One bracket will subtract the square root of n squared, which is n. one bracket is simply going to add this part that we have in the first bracket. So now we have factorized our expression completely. That is to factorize completely. So that was our question. We've got 2 marks for that. All right. Question number 3, we are given m and n. Evaluate giving your answer in standard form. All right. So we are given m and n. The first part is to add. All right. Remember, I said whenever you are adding, it's best for you to add these numbers in ordinary form. If you're dealing with addition, try by all means to add these numbers in what? In ordinary form. Not to say that if you work in standard form, you're not going to find the answers. No, you're going to find your answers, but it's best for you to simplify in standard form, in ordinary form, I mean. So in this case, we are going to start by evaluating this in ordinary form. M is equal to 2 times 10 to the exponent of 3, meaning to say we are multiplying by 1,000. 10 to the exponent of that's 1,000. 10 times 10 times 10. So we are simply going to obtain 2 times 1,000, which is what? Which is 2,000. All right, we move on to m. M is 5 times 10. This one is direct. 5 times 10 is going to be what? It's going to be a 50 in this case. All right, so we are going to add our terms. As I'm saying, it's easier for us when dealing with addition and subtraction to add these in what? In ordinary form. So let us add and see. So the item A here, m plus n, is going to give us what? M, we said in ordinary form is going to be 2,000 plus 50. So this same way or same presentation is same as just writing this as 2,000 plus 50 like this, which is going to be 0 here. That's a 5. That's a 0 here. That's a 2. But this number that you're obtaining, it's in ordinary form. It must be in standard form. Remember, our number in standard form must be between 1 and 10. So we're going to move the comma from where it is. We are given a whole number. So the comma is right at this place. So we're going to move our main commas 1, 2, 3 up to this number. It's now 2,050, which is 2,05. This 0 does not affect us. Times 10 to the exponent or 10 to the power of what? The number of commas that we move. We moved our main commas 1, 2, 3. We moved 3 commas. That is going to be your power. And also to note, you started with a whole number, a significant figure. So your answer is going to carry a positive exponent. If you have a decimal 0, if it was 0, something, your answer is going to carry a negative exponent. That is the idea there. All right, the other part on B was to divide. The B part now we are given to simplify. So like I said, for division now, it's best for you to work in what? In standard form. So this one, it is best for us to simplify in standard form. Addition, subtraction in ordinary form. So why is that? So if you have to check our numbers here, we are given to simplify n over m. So we've got n over m, which is going to be n, that is 5 times 10 to the exponent of 1. So this is same as 5 times 10 to the power of what? Of 1 over m, which is 2 times 10 to the power of 3 in this case. So the advantage that we have is that we can simply divide these numbers separately, and we also divide this part of exponents and bases separately. So let us divide 2 into 5. That is going to be 2 times into 4. We've got a remainder of 1. That's comma. We put a 0 here. 2 into 10. That is going to be 5. On this part, like I said, we are going to separate this. And we know that on our division, if you are dividing the bases which are the same, you subtract the exponents. So in this case, you are going to subtract the exponent, that is 1 minus 3, under the same base of 10. So it's going to be 10 to the exponent of 1 minus 3. So that is going to be 2,5 times 10 to the exponent of minus 2. Already this number is in standard form. It's between 1 and 1 to 10, and also having a base raised to a certain power, that is 10 to the power of. So that was the simplification on this part. Question number 4, we are given, sorry, let's check here. All right, sorry for that. I want to change this part here. All right, so on this one, we are given that in a certain month, there was an exchange rate that was happening for a certain month, whereby we are given that in a certain month, 1,402 pounds was equivalent to 2,000 US dollars. calculate the equivalent value of the exchange rate in form of, so take note, we are given the format $1 as to what? In terms of pounds in this case. So what you simply take is a proportion from what? From the US dollars in this case, because that is the one that you're supposed to refer in the form. So we are simply saying in form of the US dollar, we are given that 2,000 for that particular month was equivalent to what? To 1,402 pounds. What is going to be the equivalent of $1 in this case? What is going to be the equivalent in form of pounds? That is N representing what? The pounds in this case. So as you can see from our simple proportion, this is going to be a less. That is 1 over the 2,000 times the amount that we are supposed to have in pounds. So it's going to be 1 over 2,000 multiplied to, in this case, we are going to have 1,402 pounds. All right, so let us multiply. On your simplification, we can check that here there is a 2,000. And here there is also a multiple of a 2 in this case. This 2,000 is a multiple of 2. And this number also is a multiple of 2. So if you can just divide by 2 here, you're going to obtain 1,000. You divide by 2, that's a 7. By 2 here, that's a 0. By 2 here, that's a 1. What is the advantage of maintaining this? Because we know that by dividing by 1,000, I'm going to simply move the number of commas from this number that I'm having. I'm going to move 3 commas to the right. We are dividing by 1,000. So that's 701. We just move 3 commas to the left. That's 1, 2, 3. So our comma is at this point. So meaning to say our answer is supposed to be 0, in this place, supposed to be 0,701 in terms of what? In terms of pounds. That was supposed to be the equivalent. So the format is the US dollar is equal to how many pounds? We can simply say in terms of $1 in this case, in terms of $1, it is equivalent to 0,701 pounds in this case. All right, so that was what we're supposed to have answered in this question. Then we are now given in another month, the exchange rate was, this is no longer about this part. We are now talking about another month. This was on its own. We covered this part. Now they're asking us that in another month, another condition, the exchange rate this time was at $1 as to 0,69 pounds. Calculate the equivalent of 2,760 pounds in US dollars. We are working with this condition. So again, you use your simple proportion to say $1 is equivalent to how many pounds in this case? It is equivalent to 0,69 pounds. What is going to be the equivalent in this case from the pound that we are given of 2,760? What is going to be the equivalent in US dollars? So again, from our simple proportion, this is going to be more. As we can see, this value is bigger than 0,69. So it's going to be this value over this value times the amount that you are supposed to have here. So that's 2,760 over the total over 0,69 multiplied to what? To the $1 in this case. So the moment we are going to multiply this to the $1, we are going to obtain our amount in US dollars. All right, so if you have to divide this, we are going to obtain something like 4,000. So that was going to be 4,000 US dollars in this case. All right, so that is how we are supposed to attempt these typical questions. It's a question that is related to proportion. From the information that you have, you can relate this to our proportion. So that was 1 mark and 2 marks for the other one. So as we can see, this was a little bit direct, just that we need to be careful on our proportion concept. All right, so let us check the other part. Now we are given the dimensions of a rectangle measuring 32 centimeters by 24 centimeters are enlarged in the ratio of 5:2. All right, so that was our question 5. Find the new dimensions. How do you enlarge from the given dimensions of a certain shape? How do you enlarge them to give us the new dimensions? Take note, in this case, we've got an enlargement of the ratio of 5:2 in this case. That's our enlargement. 5:2. So we are enlarging in the ratio of 5. This is our enlargement. So what we are going to have for the 32 centimeters, we are going to enlarge this in the ratio of 5:2. So we're going to have 5/2 times the enlargement times the side that you're supposed to enlarge, which is 32 centimeters in this case. So you're going to multiply the enlargement, to the 32 centimeters, this one, all right? That is the first enlargement that you're going to have. So that is going to be something like 16 here, 16 times 5, which is going to be 80 centimeters. So the same thing on the 24 centimeters, the enlargement of 5:2, the smaller one, times the 24. So that is, we have enlarged the 24 centimeters 2 into this. That is going to be 1 into 20 into 4. That's a 2. 12 times 5, which is going to give us 60 in this case. So we are obtaining 60 centimeters. So our dimensions before were being 32 centimeters by 24 centimeters. Now our dimensions, they are going to be 80 centimeters by what? By 60 centimeters. So this is the new enlargement that we have from the original dimensions that we had. So here we're just supposed to write the new dimensions that we got. That was 80 centimeters by what? By 60 centimeters. Already the centimeters is written here. So already it's written for you. So you are not gonna write this part. So when you are given that part, you have to work with the way your paper is presented. All right, on question number 6, we are given the vector, in this case, given vector AB and vector BC. All right, we've got vector AB and BC. Write vector AC as a column vector. In this case, we are already given the displacement vectors. So we are simply taking a route, or we're supposed to take a route or a direction. In this case, let's say we are on a triangle like this. This is point A, this is point B, this is point C. These vectors being taken from the origin, which is our center O. So we are given vector AB from A to B. This is what we have, which is 10 minus 4. And we are also given BC from B to C like this, which is 2 minus 8. This is our vector. And our question is asking us to calculate AC. So it's a route that you are simply going to take from A to B, then from B to C. Instead of moving from A to O, we do not have this information about the center. We only have the displacement vector. So meaning to say AC, we are going to move from A to B, then we move from B to C. So that was the idea of our question. Just connect here A, B, B, C. As you can see, these can be connected together. So we can just apply this direct information. So from this part, what we need is to substitute our vectors. In this case, we are going to take our vectors A, B, and the vector B, C, substitute into this vector that we are given. So that is going to be A, B, which is 10 minus 4 in this case, plus vector BC, our vector BC, which is 2 minus 8. We are maintaining the arrow, as you can see, which corresponds to what exactly we have. It's maintaining the arrow, so it's going to be 2 minus 8. So this one was just combining the vectors that are given, but having your answer as a column that is in column form, that is in terms of X, Y, like this. That's a column form. So let us combine our terms. Remember, I said corresponding elements, you just have to add 10 plus 2, which is going to be 12. You add also the corresponding elements. So this is minus 4 plus minus 8, minus 4 plus minus 8, like this. So a plus and a minus is going to give us a minus. So you add the numbers because the signs are the same, you obtain a 12, but carrying the common sign, which is a negative. So that was going to give us a negative 12 in this case. All right, so that is our vector AC. All right, the B part, find BC, leaving your answer in set form. That is the modulus of BC in this case. These two lines here, they indicate the modulus of a vector. So you're supposed to calculate the modulus of vector BC, leaving your answer in set form. Leaving your answer in set form, that is leaving your answer in terms of the square root of. So let us check. We have our BC already here. So remember the formula for the modulus. We stated about this, that the modulus of a vector is given from what? The square root of x squared plus y squared, whereby the x here and this is our y. So we are going to have the square root of x squared, which is 2 squared in this case, plus the value of y there, which is -8 squared. So that is going to give us the modulus of our vector, which is the magnitude of vector BC, which is the length of BC. 2 squared, that is 4, plus -8 squared, that's -8 times -8, which was going to be a 64. You add the numbers here, you are going to obtain 68. So this number is already in set form. You can leave it like that. It's length, which is measured in units, or you can simplify further, since we know that we can simplify in set form. Remember that the square root of 68, you can choose the highest perfect square in 68, which is, you can write this as 4 times 17 in this case. If you multiply 4 times 7 is 68, whereby the square root of 4 is 2, but we can't determine the square root of 17. So this was supposed to be written as 2 square root of 17. Or you apply the longer way that I stated, that if you want to express in set form, in simplest form, you simply have to divide by the smallest number with dealing with our prime factors. So start with 2. 2 into 6, that's 3, into 8, that is 4. 2 into 3, that is 1. We've got remainder of 1 into 7. 17 into 17, that's a 1. So I say that where there is a pair, wherever you see a pair of numbers, in this case, there's a 2 and a 2, this part here, you write this pair of 2 out of the square root. So this is the 2 that we see out of the square root. The number that is not having a pair, you write it inside the square root. So you're simply going to obtain 2 square root of 17 from this way. A number, it's a pair of 2. So you don't write 2 times 2, no, it's a pair of 2. A pair of 2, that is the idea. A pair of a certain number. So that was the idea of our question. So meaning to say here, that was just 1 mark and 1 mark. So you're just going to write your answers 12 minus 12 in this case. Then on this part, we got the square root of 68, or they can give even this as the 2 square root of 17. So it's going to depend with how the answers are being presented on your final presentation. So you can write in simplest form, but as for sets, even if your answer is not in simplest form for a particular question, which is not about sets, like the topic is not on sets, they will actually mark you correct, even if you leave that answer in another format, which is not the simplest form. All right, on number A of question 7, find the gradient of a line L which passes through the point 6, 8, and 0, 5. So if given 2 points on a line, so remember to find the gradient, you're just gonna have x1, y1, and we've got x2, y2 in this case, whereby we say that the gradient of a line is simply the change in y over the change in x. So that means our gradient is going to be y2 minus y1 over x2 minus x1. The change in y over the change in x. Y2, that's 5. Y1, that's 8. So it's going to be 5 minus 8 over x2. Our x2, that's a 0. Our x1, that's a 6. So that's 0 minus 6. So this is paper 1. You're supposed to simplify everything stage by stage. So 5 minus 8, that was going to give us -3. 0 minus 6, that was going to give us a negative. So cancel this, 3 and 3, that's 1. 3 into 6, that was going to give us a 2. So meaning to say the gradient of this line is going to be equal to what? It's going to be equal to 1 over 2 in this case, the change in y over the change in x. And some people, they ask, if I use y1 minus y2, am I going to have the same answer? Guys, this is same part or same concept. Even if you are to use y1 minus y2 over x1 minus x2, you are supposed to obtain the same answer in this case. Let us take our points. Remember, y1, that is 8. So we're going to have 8 minus y2, which is 5, over x1. Our x1, that's 6 minus 0 in this case. All right, so you can simplify this part separately. So what are we going to have? 8 minus 5, that is 3. 6 minus 0, that is 6. So you can reduce by 3, which is 1, by 3, that is 2. So you're going to obtain 1 over 2 in this case, which is the same answer. All right, then on number B, they are saying find, take note. Let's be careful about this one. Find the equation of a line which is parallel to L. Remember, we're talking about L, line L in the previous part. We calculated its gradient. Now they are saying we are supposed to find the equation of a line that is parallel to L and passes through the point 4 minus 3. All right, let us take the part that this line is parallel to L. What is the idea that we take from parallel to parallel, lines that are parallel to each other? All right, if two lines are parallel, they have the same gradient. So meaning to say what we are going to take there is M, which is the gradient of 1/2, because these two lines, they are parallel. Remember I said M indicates the gradient. So our gradient there is going to be 1/2. That is the gradient of the line parallel to. If they are perpendicular, they can give us a condition that the lines are perpendicular. When the lines are perpendicular, the product of their gradients, the product there of their gradients should give us -1. The product of their gradients should be -1. Is equal to -1. Dealing with the gradients, you multiply the gradients, you get -1. Meaning to say on these ones, if you are given that these two lines are perpendicular, I was going to say half times the gradient of the other line that I do not know is supposed to give me a -1, because the product must give us a -1. So how can I find the value of M? I can simply multiply here by 2, multiply here by 2. So that means I'm remaining with M. So M is going to be -2. That is if these lines were perpendicular, but this time we are given that these lines, they are parallel. So we are not going to use the perpendicular concept, but they might ask you a condition that they are perpendicular. So this one, they are parallel. So you take the gradient, because parallel lines have got same gradient. So knowing that the equation of a line, we are given also the point where this point is going to pass. Is going to pass through the point 4 minus 5. So we have a gradient there, and we have a point which is 4 minus 5. How do you calculate the equation of a line given a point and a point and a gradient? So you can use the y-intercept formula. Y is equal to mx plus c. Remember, this is the format of a straight line where m is the gradient. So you're going to substitute your m, the gradient, which is 1/2x plus c. So you have to find C from where? From the point that you are given. This is X, this is Y. So the value of X there is negative. The value of Y is -5. You substitute Y, -5 is equal to 1/2 times X, of which our X at this point is 4. So that's you're going to find C. Half of 4, that is 2. If you transpose 2 to this side, it's going to be a negative. So that will be -5 minus 2 is equal to C, which is -7. Is equal to C. So therefore, our equation now is going to be written Y is equal to mx, which is half of x plus what? Plus C, whereby our C is -7. So that is going to be the equation of the line. Y is equal to the half of x minus 7. Or you can have this equation. There are so many ways, guys, of finding the equation of a straight line. It's not like you're supposed to work with the intercept formula concept alone. We know that if you are given the gradient and a point, the equation can be taken from the concept that y minus y1 over x minus x1 is equal to the gradient, which is m. So we are simply saying y minus, this is going to be referred as y1 as x1. The point now, this y and x, these ones, they are variables. These ones, they do not change. They are not substituted by any value. Y1 and x1, these are the values that you're obtaining from what? The point that you're given. So it's going to be y minus y1, which is -5. So it's going to be minus over x minus x1. Our x1 there is 4. This is going to give us the gradient, which is 1/2. So you can simplify minus and minus, that's a plus in this case. So meaning to say you combine this part with a plus. So what are we going to have at the end? If we combine this with a plus, we are going to have at the end y plus 5. So let's see, y plus 5 over x minus 4, which is equal to 1/2. So you can cross multiply to remove the fractions. So that is going to be 2 times y, which is 2y plus 2 times 5. You multiply each and every term, which is 10. 2 times y, which is 2y, 2 times 5, which is equal to, you cross multiply 1 times x, which is x, 1 times -4, which is -4. So that is going to be our equation, whereby you can write as 2y is equal to transpose this to the other constant. There is going to be a -10, since this is a +10. On this side is going to be a -10. So we are going to have 2y is equal to x minus 4 minus 10. That will be minus 14. So you can write your equation in this form, which is one and the same thing, right? That's one and the same answer. If you have to check here, let's say we wanted to write this equation in this format, we are simply going to divide y is equal to x minus 14. Simply divide by 2 by 2 by 2. So that's y is equal to half of x minus 2 into 14, which is a 7. So as you can see, we are obtaining the same answer just like this one that we had in the first place. All right, so that was the first part of this. Okay, not the first part actually, but I mean, in our discussion, we shall talk about these questions more and more as we move. There are so many question papers that we need to answer, so many. And also I said we are supposed to be talking about combined science in the next classes. So make sure that you are ready for that combined science, physics, chemistry, and so on for our O-level and so on. So please be ready for that. Number 8, by correcting each number to one significant figure, estimate the value of. Take note, by correcting each number to one significant figure. Each number. All right, so we have got 371 divided to 849. So we're going to run, or we are going to estimate each part is estimated. So to one SF, let's start with a 3. So 7, is it going to change 3? Yes, this one is going to change 3 into a 4. So that is going to be 4. The rest of the values will be represented by the zeros. So it's going to be 400 divided to, we check 8. Is the 4 going to change this 8? No, 4 is less than 5. So 8 is going to remain as it is. The rest of the values represented with zeros. That's how you round off to 1SF. All right, then we are going to have the square root of 6. The first digit, is 6 going to change this 6? Yes, it's going to change into a 7. The rest of these digits, 0, 0. Minus, you check the 6, is the next digit going to affect 6? 4 is less than, so it's not going to affect, so it's going to be 6, 0, 0. All right, so on top, we are going to divide 400 divide by 800. That's a half, or 0.5. That's the same as 400 over 800. That's what they say, 400 divided. So these zeros cancel. 4 into 4, that's 1, into 8, that is a 2. So 2 into 1, that is going to give us a 0, comma, we put a 1 and a 0 there, which is going to be 5. So 1 over 5, 1 over 2 is same as 0.5, guys. All right, so this one was going to be 0.5 over the square root of this, but we are supposed to simplify first what is inside of our square root. So we are going to be left with the square root of 700 minus 600, which is 100. So that's 0.5 over, remembering that the square root of any number, it's a plus or minus. So you check also on your indication of your answer. In this case, we can choose to use the plus or minus or not. As you can see here, do not have a part that has got 2 answers to be written. So you can choose to have this plus or minus or not. If you are to use the plus or minus, it is going to be plus or minus 10. Then at the end, we are going to divide. So dividing, we are dividing by 10. So you're simply moving 1 comma to the left. So you move 1 comma to the left. That's our comma is at this point now. So it's going to be 0,005. But take note, we've got a plus or minus 0,05. The comma is here. This is where the comma is. So it's 0,05. Or like I said, on the simplification part, this plus or minus even is not even considered. It's not even important. So you can even write it as a fraction or even as a decimal. It's just one and the same thing. As a fraction, it was going to be 0,05. How many digits are we having in this case? I mean, the numbers that we have after the comma, they are 1, 2. So meaning to say we are dividing by 100. It's a 5 over 100. Then we can cancel 5 into 5, 1 into 10, that is 2 into 0, that is 0. So it's going to be 1 over 20. That's as a fraction. 3 marks for that. All right, that was fine. Number 9, D is proportional to the cube of n. Take note, to the cube of n, it means to the exponent of 3. If they say the cube root, if there is a root, then it means the cube like this. But here it's just the cube, that's to the exponent of 3. So it's a direct variation in this case, whereby we are given that d varies directly or is proportional to the cube, that is n to the exponent of 3 in this case, all right? So it's going to be n to the exponent of 3. A, express d in terms of n and a constant k, and you are given a constant to use. In that case, you have to follow the way that you are given. So the A was going to be d is equal to, just introduce your constant. Remember, introducing a constant, it goes together with what? The equal sign. Then this part on B, we are now given that n is equal to 3 when d is equal to 21. And this part here, it's on its own. It's an information that you are supposed to work with. Find this. It's another question that you are given. And we are talking about something else there. What is it that we are given? From what we are given, what is it that we are supposed to find? From this given information, you can calculate the value of k. How are we going to do so? We are going to substitute, since we say d is equal to k to the n to the exponent of 3, we are given that at that moment d is 21,6. So 21,6 is equal to k times n to the exponent of 3, which is 3 to the exponent of 3. Our n there is what? Is 3. So we are going to have 21,6 is equal to 3 to the exponent of 3 to the power of 3. That's 3 times 3 times 3. 3 times 3, 9 times 3, which is going to be 27k. So how are we going to find the value of k? That is the question. Before we answer the question, how are we going to find the value of k? Divide by 27, divide by 27. So by dividing by 27, we are going to obtain the value of k in this case here. So let us divide by 27, meaning to say we are going to obtain our k as, if we divide, we can divide by 3. Okay, just reduce your numbers here by 3. That is going to be 3 into 21, that is 7, comma 3 here, 3 into 9, that is going to be a 2, 3 into 27, which is a 9. Then we can divide by 9 direct. 9 into 9, that is 1. 9 into 7, that is going to give us a 0 in this comma. We put the 7 here. 9 into 72, which is going to give us 8. That's 0,8 in this case, all right? Or 0,8, which is same as a fraction, that's 8 over 10. 8 over, we've got one decimal place, so that's 8 over 10. Can reduce by 2, that is going to be 4. By 2, that is going to be 5. So meaning to say, our k is 4 over 5, but that is not our question. Our question is not for us to calculate k, no. Let's go back to the question. The question is now, find d when n is equal to find, we are to find d. This information, it just helps you to find the value of the unknown, which is our k, our constant, because that one is a constant, does not change. So the question now is to find d when n is 5. We are given that this time n is equal to 5. Find d. So what are you going to do? We are going to substitute this information on our d. In this case, where there's a d here, we are going to substitute the k that we obtained. So we are going to have this as d is equal to, remember, we got our k as 4 over 5 or 0,8. So we are going to have 4 over 5 in place of k. That's n to the exponent of 3. But remember, we are supposed to find d given that n is 5. So we are simply going to substitute the value of n, which is 5 in this case here. So that is going to give us d is equal to 4 over 5 times 5 to the exponent of 3. So what are you going to have at the end? That's 4 over 5 times 5 to the exponent of 3. That's 5 times 5 times 3 times, which is going to give us 125. So you can simplify further. 5 into 5, 1. 5 into 12, that is going to be 2. In this case, we've got a remainder of 2. 5 into 25, which is 5. So you can multiply 4 times 5. That is going to give us a 100 in this case. All right, so that is the value of d, which corresponds if our value of n was going to be what? 4 over 5. So as we can see, the first part here, it was for this d in terms of, so it was going to be d is equal to kn to the exponent of 3. This one, they're asking the value of d, which is the numerical value of d that we got as what? As 100. So you're supposed to understand how to also present your answers on the lines that you're given there. Presenting of your answers is very, very important. All right. Then on number 10, we are given a map that is, it has a scale of 1s to 250. So this is the map of a scale. And we are given that on the A part, a building on the map has a length of 6 centimeters. Calculate the actual length of the building in meters. All right, I talked about this. It's a scale that you're talking about here. We are referring to scale similarity part, whereby here what you just need to understand is that the one here, it represents what is on the map and what is on the ground. So we are referring to two things here. What we see on the map, that is on the paper. The map is something that you draw on the paper. This is what you see direct on the ground, on the actual ground. In this case, this is what we are seeing on the actual ground, which means it's 1 centimeter on the paper to 250 centimeters on the ground. If you understand this concept, you are done to say 1 centimeter on the map is representing 250 centimeters on the ground. So meaning to say we can play around with this information to whatever unit that we want to work with, because the 1 centimeter on the map is the one that is telling us what we see on the ground. We are seeing 250 centimeters, but what is the equivalence of 250 centimeters? 250 centimeters, we can convert this to meters. We can divide by 100, since 1 meter is equal to 100 centimeters. So we can divide by 100. That's going to be 2,5 meters. So instead of writing this way that I'm given here, I can even say 1 centimeter is representing 2,5 meters on the ground, which is one and the same thing, because 2,5 is same as what? 250 centimeters. I can even go up to the kilometers. From meters to kilometers, divide by 1,000 up to whatever that you want. So you work to the part that you are supposed to work with according to the question. Our question wants us to express in meters. So simplify, just know the relationship that is happening between the centimeters and what? And the meters, to say the 1 centimeter that we are seeing here is the same as the 2,5 meters that is on the ground. So we are having a proportion again. From our similarity, we have this as a proportion to say 1 centimeter on the map is equivalent to 2,5 meters on the ground. What about a building that is on the map? Take note, the building is on the map. We are seeing it on the map having a length of 6 centimeters. So this is the map. So we are supposed to have 6 centimeters under the map. What is going to be the actual length? The actual length definitely is, we get this from the actual ground, because we are talking about the actual ground. So what is going to be the actual measurement on the ground? We are referring to what we see on the ground. In this case, what is going to be the actual measurement? So it's a proportion. 1 centimeter on the map, 2,5 on the ground. 6 centimeters on the map, what is going to be on the ground? So as we can see, this is going to be more. So that's 6 over 1 times what we have on the other side. 6 over 1 times 2,5, which is in meters. So our answer is going to be in meters. 6 times 5, that's a 30. We have a 3 there. 6 times 2, that's a 12 plus 3, which is going to be 15. Then we've got 1 decimal place here. So we're going to have 1 decimal place after the comma. So our answer is going to remain as 15. So meaning to say on the ground, the building that we see is 15 meters. But on the map, we are seeing this building 6 centimeters on the paper. The map, we are talking about what we see on the paper. All right. The item 2 is saying the area. Take note, the moment we read this, the area, meaning to say we are supposed to be relating what is happening on the map and on the ground in terms of area. This one that we see, we are talking about the ground length. It's referred to as the scale factor. This one is our scale factor, the one that is giving us the ratio of the side of the building on the map to the side of the building on the ground. It's referred to as the scale factor. So when you are answering a question for area, you're not going back to this part that we mentioned here to say 1 centimeter is going to give us this. What is going to be 10 square centimeters? No, it's wrong, because you're talking about centimeter here, square centimeter. These two are no longer together. They are no longer corresponding together. So how do we relate? That is the question. We relate this according to what is in square meters, and what is in square meters is the area factor. So like I said, this year we're talking about the scale factor, which represent the ratio of what? The ratio of sides. So the ratio of sides in this case. So we are going to need the area factor, since we are given the area on the map of 10 square centimeters and we are asked to calculate the actual area. We are going to need what? The area factor. So in this case, our area factor, how do you find the area factor first? The area factor is simply taken from the scale factor. You just square. Remember, area is measured in square units to the power of 2. That's the square units. So we are going to square. But which part? Remember, our answer is needed in square meters. So you're not going to square this one in centimeter. You need to change those units again. So avoid that. Just work with direct this part that is already in what? In meters, because we are saying 1 centimeter gives us 2,5 on the ground. So to find the area factor, we're going to simply square that 1 centimeter as to 2,5 meters. Our scale factor, we square it, because our units, they are supposed to be in square units. That is it. So 1 squared, that is 1 squared is 1 centimeter squared. All right, as to 2,5 squared. So we're going to raise 2,5 to the power of 2. That's 2,5 times 2,5. Just multiply. We know that 25 times 25 is 625. And we have got 2 decimals here, so it's going to be 6,25. So this at the end is going to be 6,25 square meters. So what it means, guys, is that now you have the area factor. The area factor, this is the ratio that corresponds when you are talking about area of what is on the map and the area of what is on the ground. So it simply means 1 square centimeter that we see on the map, it is equivalent to 6,25 square meters that we see on the ground. This is what we see on the map. This is what we see on the ground in terms of area, not in terms of length. So that's why you are supposed to find the area factor. So from this now, we can ask yourself to say, on the map, we are given that there is 10 square centimeters on this map. So if there is 10 square centimeters on the map, remember we are under the map, what is going to be the corresponding area on the ground now? The actual area, it's what we see on the ground. So it's a simple proportion again. From our simple proportion, this is going to be a more. So that means at the end, we are going to have 10 over 1 times the area in square meters. So that's 10 over 1 times the corresponding area in square meters. That was the idea there. Multiplying by 10 simply means we move 1 comma to the right. So we are going to obtain 62,5 square meters. So that is the whole idea of our question. So here, the first part here, as we saw, that we got 15 meters. The other part, 62,5 square meters. Already the units are written for you. You don't write meters, square meters. No. Already they wrote these units for us. So we are just having a continuation from the units that we are already given. All right, so that was what we had on question number 10. Let's consider the other part of our question. There we are given question 11, bearing. All right, so let's check 11, first part of our question 11, which is the bearing. What is it that we are given here? All right, that's 11A. We are given that the bearing of A from B is 243. Write down the 3-figure bearing of B from A. So we have to first indicate the one that we are given. A as it is taken from, that is the most important part, from B. We are taking A from B. So this is what we have in actual sense. This is from B. We are going to have our north pole at B. This is a 3-figure bearing. Compass bearing is the one that we see with the poles, north 30 degrees east, south 45 degrees west. This is compass bearing. Once you are given without these poles, the north pole and so forth, it means we are talking about a 3-figure bearing, which is always taken in the clockwise direction. So this bearing is always taken in the clockwise direction from the north pole, always in the clockwise direction from what? From the north pole. So that is what you're going to consider, meaning to say from our north pole, where do we expect to obtain 243? 243, this is 90, this is 180, this is 270. So 243 is less than 270, maybe somewhere here. So this is where we expect to have an angle of 243 taken in clockwise direction from the north pole in clockwise direction. So this angle is 243 degrees. So that's where we have the point B. So the point B is the one that is from this north pole. So where B is going to reach, we are saying it's A from B. So meaning to say this line, as it goes this side, we are going to meet at the north pole that is at A. Let's say this is where we have point A. We are going to indicate a north pole there at point A. So this is the north pole for point A. And what is the idea of the north poles? Remember that these north poles, they are parallel. They will never meet. So if they are parallel, they maintain the properties of parallel lines. That is the idea that we are going to use to find the bearing now of B from A. The question now needs us to find B from A, that is from a 3-figure bearing. That is, like I said, is taken always clockwise direction from the north pole. So from the north pole in a clockwise direction, this is what we are going to have. From the north in a clockwise direction, this is the angle that we are supposed to cover. So we need to find this angle. This angle here is the same as this angle that we see here. If we are to find this angle in between this south and this these two angles, they are equal. What is the condition? Remember, I said these are parallel lines. So as you can see here, we are forming a Z, alternate angles. So that means this angle and this angle will be equal. How do I calculate this angle that is remaining here? Remember, the whole of this angle is 243, and we have a straight line whereby we know that angles on a straight line, they add up to 180. So we are simply going to subtract 243 minus 180 degrees. We find the angle that is remaining at that point. So this angle is going to be 63 degrees. But we are saying this is a 3-figure bearing. Here you can write, yes, 63 degrees. But on the answer now, the bearing of B from A, it is going to be equivalent to 0.63. 3-figure bearing. Our answer is supposed to be having what? 3 digits. That's 1, 2, 3. All right, so that was the case of our question. The B part, from the list of numbers below, choose the rational numbers. From these numbers, we are asked to choose the rational numbers. Actually, we had, I think I have actually referred to another video about these things of rational and irrational numbers. And I listed the other number here, the 22/7, that one, I actually listed it wrongly. I want you to understand this part. I want you to understand because what I explained there, and I think it's going to make some misunderstanding there. The rational numbers, we are referring to a number that can be expressed as a fraction of 2 integers. It can be expressed as a fraction of 2 integers. It can be a whole number. It can be an exact decimal. Also, it must have a denominator that is a non-zero digit. The denominator is supposed to be a non-zero digit. So meaning to say, on listing our rational numbers, 22/7 is there. If we check our definition of rational numbers, it's saying a number that can be expressed as a fraction of two integers. We've got two integers in this case. So 22/7 is among the rational numbers. It's not an irrational number. That one is actually wrong. But I think I've actually listed this on, I still remember that video. So please make sure that you correct that part. It's a rational number. But this pi that we see, that it's an irrational number, because this pi, when we are considering it, we are considering as pi that we know from our calculator, which is an endless decimal, This one that we see, it is a fraction of two integers. So it becomes a rational number. Please, on this part, I want you to be very careful, because I explained this before, and is something else. All right, so the other one, 2,3, it's an exact decimal. So that's 2,3 is going to remain a rational number in this case. We move on to the square root of 48. The square root of 48, we can't determine this. We can't express this as a fraction of two integers. We can't express this as a fraction of two integers. If we check 2,3, it can be expressed as a fraction of two integers, because this is same as 23 over, we've got one decimal place, 23/10. So it can be explained. These are integers. So meaning to say, we are going to have this square root of 48. We can't have this. The cube root of -8. The cube root of -8, remember, that's -2. -2 times -2 times -2. It gives us -8. -2 times -2, that's 4. 4 times -2, that's -8. So meaning to say, we can take this, because the cube root of -8 is -2, and -2 can be expressed as a fraction of two integers, -2 and 1. These are integers. So meaning to say, this is also part of our irrational numbers, of our rational numbers, in this case, the cube root of -8. So please, I want you to correct this part. These were the the rational numbers that we're supposed to have. Irrational numbers, they are the ones that oppose what we are saying. We can't express them as fraction of two integers. And those are the ones that can have a denominator that is a 0. In this case, our denominator is supposed to be a non-zero digit, and a fraction is expressed in terms of two integers. If you express it as a fraction, this is supposed to be an integer value. This is supposed to be an integer value. Once it maintains this, that number is a rational number. So please do your best to correct this part. And if something has been said before, and now you said in another way, to be like, what is happening here? But please, like I said, can we just try to work on it and correct that part? All right, so let's see the other part. Right, I want us to see the other part here. So this one is just 3 marks, expressed as a single fraction. All right, so how are you supposed to express this as a single fraction? 3 marks for that. All right, that was our question number 12. So in this case, we are given to express 3 over x minus 2 minus 4 over x plus 1 as a single fraction in its simplest form. So, all right, here I'm going to explain 2 ways. It's very, very important that we have this question. I was actually thinking of finding a class that we can express of this other method, but let us just see. Let's see here. So in order for you to add, remember our basic method was to have this as to find the common denominator of the given denominators that we have, which is x minus 2 and x plus 1. And our common denominator in this case is going to be x minus 2, and we also have x plus 1. We just take everything as it is. We divide back our LCM, x minus 2 and x minus 2. These, they cancel, but do not cancel. You're supposed to see that this one and this one cancels. You remain with x plus 1. So this x plus 1 is going to be multiplied to 3 in the numerator, like this. All right, minus, we do the same. The x plus 1 and the x plus 1 here will cancel. You remain with minus 4 into x minus 2 in this case, like this. All right, expand the brackets so that you can collect like terms. 3 times x, that will be 3x. 3 times 1, that is going to be a 3. All right, minus 4 times x, this will be minus 4x. Minus 4 and minus to take dot minus and minus. So that one is going to give us what? A positive, which is going to be a positive 8. minus minus, that's a positive. Everything over what? X minus 2 into x plus 1 in this case. All right, then collecting our like terms, we are going to have 3x versus 4x. So 3 minus 4x, that will be a minus x. So this was going to give us minus x. Then we've got 3 plus 8, which is going to give us 11. Everything over x minus 2 into x plus 1 like this, which is same as 11 minus x over this is just one and the same thing. All right, so I was saying we could have simplified, or we can simplify this in this other way, whereby you just ask yourself like, all right, let me have it this way: 3 over x minus 2 minus 4 over x plus 1. We know that if the denominators are the same, we can simply subtract or add whatever that we have. We can simply combine, like if we've got 3 over 7 plus 2 over 7, because the denominators here are the same, we can simply add our numbers under the same denominator, 3 plus 2, which is 5 over 7. We can simply do that because the denominators here are the same. So we can think of that to say, how can we make these denominators to be the same? So you simply have to add what you are not having from the other fraction. Like what I'm saying is that here there is x plus 1. We do not have x plus 1 this side. So you multiply by x plus 1 over x plus 1. That is, you have added x plus 1 to this denominator. But whatever that you do must be done on both on the numerator and what the denominator. The same thing here on x plus 1. We do not have this x minus 2. So what are you going to do to have the x minus 2 this side? We simply multiply by x minus 2 over x minus 2. So that means at the end, this whole part is going to give us 3, is going to multiply x plus 1. So it's going to be 3 into x plus 1 over what? Over x plus 1 into x minus 2. Minus 4 is going to multiply on top x minus 2 over what? Over x plus 1 into x minus 2. Do not cancel this, because the moment you cancel, you are going back to this fraction that you had before. So your idea of multiplying here was to make sure that these denominators here, they will be the same. As we can see, they are the same. So what are we going to do? We are simply going to combine our numerators together. Like I said, if the denominators are the same, you can combine the numerators together. So meaning to say here, we are simply going to combine our numerators. So everything over what? Over our denominator of x plus 1. So it's going to be x plus 1 over x minus 2. So everything is going to be affected by this denominator here. So let's combine 3 times x. That is going to be 3x plus 3 times 1, which is going to be 3. Then take note here, you are using the minus to expand the bracket at once. So it's minus times x, minus 4 times x, which is minus 4x, minus 4 times minus 2, which is going to be a plus 8. So this is the same stage as what we saw before. 3x minus x gave us minus x. 3 plus 8, it gave us 11. So as you can see, we are obtaining the same answer just like the previous case or the previous part that we had. So we just have to be careful on this part, how to simplify or to evaluate this. Oh, that was 3 marks for that 3 marks. All right, let's check solve the simultaneous equations. All right, simultaneous equations, guys. There are so many methods that you can use. Just play around with the method that is easier for that particular question. So we are given the simultaneous equation of 0,4x plus 3y, which is equal to 2,6, and x minus 2y is equal to 4,6 in this case. So how can we solve this part? In this case, yes, we've got decimals, but they are not even affecting that much on this part. They're not even affected that much. So what you can do is to remove the decimals. If you are having confusion of decimals, remove the decimals. So you ask yourself, I've got 1 decimal place after the comma, I've got 1 decimal place after, meaning to say if I multiply by 10 throughout here, I can remove these decimals that I'm having on top. So just multiply by 10 to remove the comma. 0,4 times 10, that is going to be 4x. Plus 3y times 10, which is going to be 30y, is equal to 2,6 times 10, which is 26 in this case. Our major aim is just to remove the word, the decimals that we have on the same part. On the denominator here, you check the only denominator that I have is here. I mean, the only decimal, one decimal place. So I'm just going to multiply by 10. But the 10, you are not focusing on this part alone. No, you are focusing on every part. So it's 10 times x, which is going to be 10x. 10 times minus 2 minus 20y is equal to 4,6 times 10, which is going to be 46. We have removed the decimal in that case. So depending with the method that you're going to use, but as you can see here, yes, you can reduce your numbers. So here I'm just going to choose elimination here to eliminate. But like I'm saying, it's different from the part that you're going to choose to work with. But here we can just eliminate x. How can we eliminate x? We have to choose to make these to be the same. So which number are you going to choose to multiply with so that these two numbers will be the same? If we are to multiply here, we are supposed to use 10 on top and 4 below. But check if these numbers can be reduced. Reduce your numbers. Like here, we can reduce by 2. That is going to be 5. By 2, this is going to be 2. So instead of using 10 and 4, use 5 and 2. These numbers, they will be the same. If we multiply, we are going to have the same answers. So we're going to multiply by 5 throughout. This one is for eliminating x so that this part will be the same. That's why we're multiplying by 5 and 2. This part that we multiplied here by this 10 here, where we multiplied by 10 and 10, it was for us to remove the commas that we see, not to eliminate or to just to remove the commas that we see there. But now we are multiplying by this 5 and this 2. This time is to eliminate the part of x to make sure that these two terms are the same. That is the idea now. So if we multiply 5 by 4, that is going to be 20x. 5 times 30, which is going to be 150y, is equal to 5 times 26. We are going to obtain 130. 5 times 6 there, that's 30. Then 5 times 10, which is 5 times 2, which is 10, plus 3, which is 130. By 2, you multiply each and every term. 2 by 10, that's going to be 20x. By 2 here, that is going to be minus 40y, is 2 times 46, which is 92. So as we can see, these two are the same. We've got 20x, we've got 20x. Now you are supposed to eliminate x. How are you going to eliminate x from the first equation and the second equation? We can simply subtract. Since these two terms are carrying the same sign, 20 minus 20, that's a 0. So in this case, we are saying we are to eliminate x now, to remove the part that has got x, that is to eliminate x. So in order for you to eliminate x, you are going to simply subtract, since these are carrying the same sign. So 20 minus 20, that's a 0. The sign that you use here, you're supposed to use it throughout. So it's 150 minus 40. So you're going to obtain 150 minus 40y like this, which is going to be minus, that is going to be a positive. So we've got 150 plus 40, which is going to be 190. In this case, if we are to combine properly, that is going to be 190y is equal to, we subtract on this side 130 minus 92. So if we subtract 130 minus 92, that will be a 1 here, and this one becomes a 10. 10 minus 8 minus 2, that is going to be 8. 13, here it's going to be 1. 13 minus 10, which is 3, that's 8. So you can divide by 190. You can divide by 190 both sides. Thus, we are going to obtain the value of y. In this case, you can write it as a fraction or as a decimal, whatever part that you're going to obtain. In this case, this is going to be 1 into this, that will be a 5. So you're going to obtain 1 over 5, of which is a decimal. 5 into 1, that's 0, into 10, that is 0,2. So our y is going to be 0,2 or 1 over 5. You can just write whatever here that you want, a fraction or a decimal. So to find the value of x now, you can just substitute into any of these equations, that you have here. So just choose an equation where you are not having a complicated part, and to just choose a part that is not complicated. So you choose any part. In this case, I'm just going to choose this one that has got x. Since I want to calculate x there, x minus 2y is equal to 4,6. There I can just make x to be the subject of the formula, meaning to say x is going to be 4,6 plus 2y, in this case, transpose the negative to this side is going to be a positive. Or just substitute your values in this part. It's one and the same thing, right? Just substitute your values on this part. It's just one and the same thing. So we are going to have 4,6 plus 2 times y. Remember, y is 1/5. Since here I'm having a decimal, it's best for me to work with a decimal also for the value of y. So y, I'm going to choose a decimal, which is 0,5 in this case, all right? So that means x is going to be what? 4,6 plus, we multiply 2 times 5, that is going to be 10. 2 times 0 here, that's a 0. How many decimal place that we have? We've got 1 decimal place in this case. So meaning to say, that's 0, why am I getting 0,5? This is 0,4. I'm wondering what's happening here. 0,2, sorry. So that means here, sorry for it, was going to be 2 by 2. That is 4. 2 times 0 here, that's a 0. How many decimal place? We've got 1 decimal place, so it's going to be a 0,4. So that's what you're going to have. So x at the end, we are going to add 4,6 plus 0,4. So we are simply adding 6 plus 4, that's a 10. We give a 1 here, 1 plus 4, which is a 5. So we're going to obtain 5,0, which is same as what? Which is same as 5. So we have the value of x, which is 5, and we have the value of y, which is in this case 1/5. So that was the relationship that we're supposed to have at the end from this part. All right, so just have to play around with your equations, guys. Try to play around your simultaneous equations. Know all your method. Like I say, each and every method it's best somehow, somewhere. A certain method is best somewhere. So it's good that we understand like all of the methods that we have for solving simultaneous equations. Number 14, we are given circuit geometry. In the diagram, we are given PQ, that is PQ, and RS. PQ, RS is parallel tangents. All right, this is a tangent parallel to this, and also here, this one is also parallel. Chord, this is parallel to the two tangents that we have. And we are given PQA 63 degrees, P to Q to A, this angle here being 63 degrees. And we are told that these two lines, they are parallel, also parallel to this one. So let us just consider our parallels. We know that here, as we can see, we are creating a Z. So meaning to say this angle here is going to be also 63 degrees from the Z angle concept. Also here, we are creating a Z at B to this S like this, we are creating a Z. So meaning to say this angle at B and this angle at R, they are going to be the same. Also from our tangents, we also know that angle between a tangent and a chord, as you can see, there's an angle between a tangent and a chord formed. This angle is equal to the angle in the opposite segment where this chord is creating the angle, the chord AQ. Is creating an angle at what? At B. So meaning to say the angle at B, this one is going to be 63 degrees, tan chord, angle between a tangent and a chord. So in short, we can just write tan chord, angle between a tangent and a chord. So this angle becomes 63. So these are some of the things that you can just fill in before you attempt your questions. So let us check our questions. What is it that we are asked here? A, find QAB. All right, so the first angle there was QAB, from Q to A to B. All right, already this one we found it from the parallel lines concept. We said these are creating or giving us a Z, or we are obtaining alternate angles. So this was going to be 63 degrees. So there we've got 63 degrees. Then the other angle is BAR, from B to A to R. This angle here, this angle here. All right. This angle here was actually a complicated part. How many marks are these ones? Let's see, 2 marks. Okay, let's see. Because BAR, if we are to consider what we have, I don't know, maybe they can be, because these are theorems, you might not see the theorem that, I might not see the theorem that you are seeing right now. You might be seeing a certain theorem that I'm not even seeing right now. it happens like that. It happens. So in this case, I wanted us to check something. We are asked to calculate this angle BAR in this case. That's BAR. Let me check again. That's BAR. All right, BAR. That is the angle, this one. This is the one that you're supposed to calculate. So far, we said this angle BAR, this one, and this angle, they are equal. The angle R, this one, they are equal from the tan chord angle between a tangent and a chord. This angle gives us the angle at A. So these two angles, they are equal. All right. The other thing that we know is that this angle and this angle there. So let us just say this, you can just write X because there are so many angles that are equal here. This angle, so you can just write X here, this angle, and this angle. All of these angles, they are equal. All right. Also, I want us to consider this. These two angles here, we are forming here opposite angles of a cyclic quadrilateral. Q to B to R to A. It's a cyclic quadrilateral. So these are opposite angles of a cyclic quad, where I say the opposite angles of a cyclic quadrilateral, they add up to 180. So if we are to add these angles here, we're simply going to subtract 180 minus these two angles, divide by 2 because they are equal. We're simply going to subtract 180 minus 63 plus 63 degrees because they are supposed to add up to 1. Then we divide by 2. The reason of dividing by 2 is that these two angles that are remaining, they are equal. That is the idea there. So meaning to say, what are we going to have at the end? In this case, we are going to have 180 minus 126 in this case over 2. So from 180, what are we going to obtain? We're going to obtain something like 54 degrees, then divide by 2. This is going to be 27 degrees. So meaning to say, this angle here is going to be 27 degrees. This angle here is going to be 27 degrees. This angle here, because all these angles are the same. If I wanted to work this in terms of X, I was going to do this because I know that these angles, like I said, opposite angles of a cyclic quad should give us 180. I'm going to say 63 degrees plus 63 degrees plus this X and this X, which is plus X plus X. I'm supposed to get 180 degrees. I solve for X. So 63 plus 63, that's 126 plus X. This is 1x, which is going to be 2x is equal to 180. So 2x is going to be, subtract this to the other side. 180 minus 126, we subtracted this before. We got 54 there. So we divide by 2. So that's the value of X is going to be 2 into, remember 1 here. So it's going to be a 27. So this X was going to be equal to 27 in this case by forming an equation or by just understanding that these two angles must give us 180, but we are saying the other ones that, I mean, these opposite angles, the whole of A and the whole of B, they are supposed to give us 180, opposite angles of a cyclic quad. But now, by subtracting these ones that we are given, these two that are remaining, these ones, they are equal. That is why we have to divide by what? We have to divide by 2 in this case, like what we did here. All right, so that was the idea. Then now they are saying, write down the special name of the cyclic quadrilateral AQBR. What is going to be the special name of this quadrilateral AQBR in this case? This is our quadrilateral AQBR, whereby if you are to take note here, because of this 63 and 63, we know that from the triangle concept, if these angles are equal, the opposite sides must be equal. The same thing from this 27 and this 27 from our triangle, it means the opposite sides must be equal. RB and AR must be equal. And as we can see, if these two sides are equal, these two sides are equal, it means there we are forming what? A kite in this case. So the special name of this cyclic quadrilateral that we see is going to be referred to as a kite in this case. Remember the properties. In order for you to know a shape that it's a kite or it's a parallelogram, it's a rhombus, you need to know the properties of that shape. You need to know the properties of the shape. So as we are revising, let's revise as much as we can the properties of the shapes that we have. All right. On another part, which is question number 15, we are given a diagram which is on our inequalities. Write the four inequalities which define the unshaded region D. So we want the four inequalities which define this unshaded region. Already here, it's an advantage. Our equations, they are already given. So the region that is unshaded is this part that we have here. We want the inequalities. If you are dealing with inequalities, there's nothing much that you are supposed to know. There is no substitution of points that you are supposed to even have. Understand this concept that I said before, guys. We have got these three conditions. I mean, they're not even three, they are just a few conditions. When you are given a line like this, not talking of being broken or not being broken, that part of being broken affects only the inequality sign. To say if a line is broken, your inequality sign can be greater than or can be less than. If a line is continuous, it can be greater than or equal to, less or equal. If a line is what? Continuous. What affects to see that it's greater or equal? This is that if you check your line, when a line is drawn in this manner, because this is how you expect your lines to be, they can have negative gradients like this. This side is always the bigger side. This side that we see here, this side on top here, this is the bigger side. So we are referring to a greater than side. This one is the bigger side. So when you see this side, it means it's bigger. If you are seeing this side, if you are working with this side here, the side that is below, this side that is below, it's less than. These values, they are less than. If you are referring to a condition like this one, if you are referring to a line of this nature, because there are just two types that you just need. You can have a line of this nature, the lines of this nature. On top of these lines, that's where we have values that are greater than. Below, they are less than. On top of this line, that's where we have greater than, less than. That is the whole idea. Working with a vertical line or a horizontal line, you can tell the top part is the greater, the below part is greater. This side is greater, this side is smaller, according to the values. So meaning to say here we are given these equations already. Let us take the first equation. I want us to relate to the same idea that we are talking about. This one is just direct, the line that is passing through this line here. We can name its equation. We are not given its equation, but we know that the equation, it's for y. It's passing through the y-axis at -2. So the equation, it's y is equal to -2. What is going to be the inequality? We are referring to the side that is not shaded, this side that is here, the side that is below, that is not shaded. So comparing these values with what is on top, and we said on top, it's greater. So these are the greater than. Below, it's less than. So meaning to say y is less than what? -2 in this case. That's what you just need to know. And this one is a broken line. A broken line is either greater than or less than. A continuous line is either greater than or equal to, or less than or equal to. So on this one, the idea here does not, my idea or this point does not even work proper. Let's see the other one. Let's move on to this one. This one, it's a continuous line. We are given this equation as 3y plus 4x is equal to 16. Check how this line is drawn. This is the continuum of these lines. And I said on top, it's greater than. Below, it's less than. On top, greater than. Below, it's less than. As we are focusing on which side, that is what you have to ask yourself. We are focusing on this side, the side that is not shaded. This is the side that you are focusing, and the side that is not shaded, it's a less than side. This side, it's smaller than the other side. This side that we see on this part, it's smaller than what we see on the other side, according to this inequality. So meaning to say, we are going to have 3y plus 4x, which is this side, is less than 16. But now the line that we are considering, it's a continuous line. So it is going to be less than or equal to 16. So if you know this idea, this one these are the only shapes that, I mean, the only presentation of a straight line. It can be having a positive gradient or a negative gradient. That's what all you need to know. All right, let's see this one. Let's see this one, if it makes sense. We are given that y is equal to x minus 8. So let's compare. We are talking about this side here. This is the side that we are talking about. The side that is not shaded, this one, this is the side that you're not talking about, that you're talking about. Here it's shaded, so, and we do not want these values, they are shaded, so you're not talking about these values. We said if a line is like this, these values below, this is the same line that you're talking like this. It's a slanted line like this. The values below this one, they are less than. The values above, they are greater than. As we are talking about the values that are above, so it means we are going to use a greater than sign. So y is greater than x minus 8. But the line is continuous, so we are going to use equal to. Just like that. Just like that, guys. This is how we answer these questions. All right. Then we've got another part here. Let's consider this one again. This one for 3y plus 4x. Already the equation is given. All you just need is to compare the line. 3y plus 4x is equal to minus 24. So let's compare which type of a line we are working with. This type of a line here. This is the type of a line that we are working. It's a slanted line like this, negative gradient. So we said on this type of a line, the one that is on top here, the one that we see on top, is greater than. And this is the one that we are focusing, because we are focusing with this side that is not shaded, this one, the region where D is. So this region where D is, this is the region that we see on top. And on top, we use what? Greater than. If we were focusing with this region that is shaded, let's say our question, let's say this region was not shaded, it means we are focusing with this side, and this side, it's less than. But here we are focusing with this other side, this one, which is not shaded, this on top. And this side here, as I explained, or on a line like this, the top part, it uses what? The greater than sign. So it means our sign here was going to be greater than. So 3y plus 4x is greater than minus 24. But check the line, is it broken or continuous? It's a continuous line, it's not broken. So the sign there is going to be greater than or equal to. So that is how we're supposed to answer this question. So we've listed the 4 inequalities which define the region that was not shaded, which is the region D. So what you just need to know is that on this line, this side of the line is greater than, this side is less than. This side of the line, according to this line, this side is greater than, it's on top, this one greater than, this one is less than. According to this line, this is the one on top, it's greater than, this one is less than. According to a horizontal line, this side on top, it's greater than, the side below, it's all the region that is below, it's less than. So that is how we take our signs. Just understanding this, guys, anything on top greater than, on anything on top greater than, anything below it's less than, zviri pasi ndo zvidiki, saka ndosashandisa chi less than, zviri pasi izvi zviri kumusoro zvinonotakura, as long unototarisa line rakoona kuti izvi zviri kumusoro kweline according to the presentation of your line. You can see that these values are above. If the line is given like this, ndotoona kuti izvi ndo zviri kumusoro, izvi ndo zviri kuzasi kunoku. Saka kumusoro iwo kana uchiconsider zviri kumusoro zvichashandisa greater than sign. Kana uchiconsider zviri kuzasi kweline zvichashandisa less than sign. No idea ingoripo throughout. So that is what you need in this part. So that was our question 15. Our question 16, in this case, we were given the limits in this case. These are the limits that we are given, whereby we are given that the length L centimeters of the edge, take note, this length L is of the edge of a cube is given by 5,1 centimeters correct to 1 decimal place. Give the limits of L. So whenever you're talking about the limits, we work with plus or minus 0,5, plus or minus 0,5 when it was rounded to the whole number. If this was rounded to the whole number, plus or minus 0,05 when it is rounded to 1 decimal place. For us to obtain a 1 digit, we must have 2 digits after the comma. If it is to 2 decimal place, we use plus or minus 0,05 when it is to be rounded to 2 decimal place in order for us to obtain 2 digits after the comma. In this case, we are supposed to use 0,05. So in this case, our question is the number that we have 5,1 was correct to 1 decimal place. So to 1 decimal place, these are the limits that we are supposed to work with. as long we are working with what? One decimal place. These are the limits that we are going to have, plus or minus. So meaning to say, our length in this case is going to be operated in plus or minus this region in this case, right? So meaning to say our length is going to be greater than or equal to the least value. We subtract 0.05 from this number, 5.1, we subtract 0.05. All right, so if we subtract this, this is the same as 0, so that will be a 1 here. 5 minus 10 minus 5, that is 5. 1 minus 1, that's a 0, comma. This one is going to be 5. So on the least value, you are going to have 5.05. Is less than. If you use the less than, then you are supposed to include the 0.05. On the other hand, the upper limit you add, so it's 5.1 plus, we add, because it's plus or minus 0.05. The maximum one you add, so this one is going to be 0 plus 5, which is 5, 1 plus 0, which is 1, 5 plus 0, which is 5. So this one is going to be less than 5.15. So this is how you state the limits. This is how you state your limits in this case. Plus or minus 0.5 if it was 5 to the nearest whole number. Meaning to say our answer, we're supposed to subtract 5 minus 0.5, which is going to be 4.5 less than or equal to L, less than. The other part, it's not equal to, it's less than, because 5.15 is not included. If we round off 5.15 to one decimal place, it will change this number to a 2. That's why we are saying it's less than, not equal to, it's just less than, because 5.15 is not included. All right, so I'm saying if this number was 5, you're going to subtract 0.5, you add 0.5, so it was going to be less than 5.5. These are the limits. All right, so in this case, we are given to one decimal place. That is why we have to work with what? 0.05. So that is how we work with the limits. Then they are saying, find the least possible surface area of the cube. Take note, we are dealing with the least value. That is the most important part, the least. So meaning to say we are supposed to work here with the least value. The least value according to the limits of our L is 5.05. So we use the least value, and the least value there is what? The least value of L is at 5.05. So this value of 5.05, which is our least or the smallest value, is the one that is going to give us the least possible surface area, or the smallest possible surface area of the cube. Take note, a cube is the one that all sides are equal. So how do you find the surface area of a cube? If you know that you're going to use this least value, what about the surface area of a cube? Remember that the surface area of a cube is 6 times side squared. Remember, a cube, all the sides are equal, and it has got 6 faces in this case. So these faces, they are equal in terms of a square. They are all equal, 6 times side squared. You calculate area of one face times 6 of them. So that is the idea of our question. So simply here, we are going to have 6 times side squared, which is side times side. So it's going to be 5.05 times 5.05. So here I want you to multiply properly. It was going to be easier if you multiply this 5.05 first times 6. See what was going to happen. 5 times 6, that's 30. Here we obtain as 0 plus 3, which was going to be 3. 5 times 3, 6 and 3 here, and 5, sorry, 5 and 6, which is going to be a 30. 2 decimal places here, so you're going to have 30.3. So it means after combining these two, we are left with 30.3. So it's going to be easier for you to multiply 30.3 and 5.05. So if you multiply properly, you were going to obtain something like 153.015, which is the area measured in what? In square centimeters. All right, so that was our least possible area in this case, which is 153.015. The limits, as we saw, that on our limits here, we took 5.05, so it's going to be 5.05 here. As you can see, greater than, they have already put the greater than there. So you use 5.15 on the other side, all right? So be careful also about this part here, how you are supposed to attempt on the least possible. I think this one I have to work it on a as a separate video because I remember talking about this, and I just need to work with another video. I think it can work, but I still remember talking about this. On number 17, we are now given, it is given that the number of elements in set A is equivalent to 18. We have got the elements which are in set A. Let's see. This one, it shows that we have got a subset. B, it's a subset of A. It's found in A. So we are given the number of elements in A, the number of elements in B, and number of elements in A union B. What does it mean? A union B, these are combination of A and B combined together. Complement, it means not in A union B. It's not found. It's not found in A union B. So meaning to say, they are saying, if you combine A union B like this, you combine everything, there is nothing that is outside. It is equal to 0, meaning to say outside here, there's nothing. All right, the number of elements in A is equal to 18. Now they want us to find the values. All right, we are given that in A, all the elements in A, they are 18. All the elements in B, they are 11. All right, A represents what we have in A and B to like this. This is the whole of A, because B is a subset. B is it's inside of A. This B is inside of A. So here there are 11 elements in B. But the whole of A, this one, is supposed to carry 18 elements. So if we have already removed these 11 elements in B, how many elements are going to remain on the outer part here, this part here, so that if we combine what is outside here and what is inside of B, we must get 18. So we are simply going to subtract 18 minus 11, which is going to be a 7 in this case. So meaning to say here, there are 7 elements, and here there's nothing. So our question here was, all right, write down the values of P, Q, and R. So here, our P, it's 0. Remember, I explained there's nothing outside of our set. So P was going to be a 0 because P is representing what is outside of A union B. Then our Q is going to give us a 7. Our R was just 11. All the elements in B represent our R. So that is the idea of this question, all right? There was nothing about, nothing much here. Then they are saying for the same given information, take note now. Take note, guys. They are saying for the same given information, which information are we given? This one here on top. This is our given information, this one. That number of elements in A is 18, number of elements in B, there is nothing between A union B complement. This is the information that we're, not the diagram, but the information. They are saying now, complete the Venn diagram to show the number of elements in each of the region where A union B is equal to 29. All right, take note, guys. They are now saying the number of elements in A union B, in this case, if you combine what is in A and B, if you combine everything in A and what is in B together, we are supposed to get 9. We are supposed to get 29 elements. So what does it mean? I want us to get back to this information that we had before. On this diagram, what made us to have B as a subset of A? It means all the elements in B are in A. And at the end, if we are to take from this diagram, from this one, A union B, the number of elements actually in A union B, they are going to be this 7 plus this 11 plus this 7, which is 18, which is the number of elements which are exactly in A, because A is consisting, or it takes everything that is in B. So we're going to have a subset concept. But this time they are saying what is in A union what is in B, we are supposed to get 29. What is in A and that what is in B combined together, we are supposed to get 29. And this information is lying from this diagram. So where is the exact information which gives us a 29? We go back to the original information that we are given here. If we check in A, there are 18 elements. In B, there are 11 elements. If we add 18 plus 11 here, you're going to obtain 29. So the only condition that can enable us to add separately what is in A to what is in B separately, it means these sets, they are supposed to be disjoint. Once B is a subset of A like this, you do not add this 11 and this 18 separate. That is wrong. The only part that you can take to say these elements, they are union to each other, it's when here there are 18 elements and these are 11, we add them together, we get 29. So meaning to say this time, A and B, they are going to be disjoint sets. But knowing that what is in A union B complement, what is not in A union B, always it's equal to 0. So there's nothing outside of A union B. So like I said, this one, we are going to have a disjoint condition. We are going to have disjoint sets in this case, all right? So here we are going to have our universal set and having disjoint sets now. A is separated to B, A and B separated, and this is our universal set. So in set A, we are going to have all the elements in A so that we get the 29, all these elements in A, which is what, 18. B is going to take all its elements. They are not going to share any element, these two, so that we obtain a total of what? A total of 18. And here there's going to be nothing, so that A union B is going to give us 29. If we combine A and B, 18 plus 11, we now get a 29. So that is the idea of this question. So we still have a lot, guys, to learn from our sets. So this one, that was the diagram. We just have to fill the P, Q, and R, determine this one. So that was 4 marks for that, 4 marks, which is actually a lot in paper 1. If you are now answering, if you are now still answering to these questions, that will be having 4 marks, and you are still feeling that you are answering, it means you are going in paper 1. That is the idea. But if you answer and you are at these questions, that will be giving you 4 marks like this, because the first one, there'll be 1 mark, 2 mark, but then there'll be 2 mark, 2 mark. If you are still answering at these questions, you are still seeing yourself in the right direction. Know automatically that you have already passed the paper, you've already obtained a good mark from there. Number 18, we are given matrix M and N are 2 by 2 matrices. So we are given M and the product of Mn. These are 2 by 2 matrices. These are 2 by 2 matrices. All right. The first question was to find the inverse of M. M to the power of -1 means the inverse of M. So in this case, we are being asked to calculate or to determine the inverse of matrix M. How do you calculate the inverse of a matrix? Remember, the first thing is to determine the determinant of that matrix, which is referred from our AD minus BC, A, B, C, D. So it is the product of the major diagonal, this one, minus the product of the minor diagonal, which is the B and what? The B and C, that is remaining. So our formula is supposed to be AD minus BC, whereby A and D, that is going to be 2 times 3 minus B times C, which is -2 times -1. So 2 times 3, that is 6, minus -2, and -2 is going to be a +2. We subtract, we are going to obtain 4 in this case. So this is our determinant. When you see these lines under matrices is determinant, under a vector is the modulus. That is the difference between these two lines. So after determining our determinant, it follows that the inverse of matrix M, which is M to the power -1, is going to be 1/4. So this one is going to be 1 over the determinant, 1/4. Then what is going to happen is that in the major diagonal, this is our major diagonal that we are having, we are going to interchange these numbers. We interchange them. Where there's 3, we put a 2. Where there's a 2, we interchange this. So this one is going to be 3, 2. In the minor diagonal, this is our minor, the part that is remaining. We multiply by a negative. This number, you multiply it by a negative. So it's negative times negative, which is going to give us what? A +2. Here there's a negative. Negative times negative, which is going to give us what? Which is going to give us a +1. So that is going to remain now as our inverse. In this case, the inverse there, these two numbers here, they are affected by a negative, these two numbers. These ones, you interchange them in the major diagonal. The minor, multiply them by a negative. Then the second question now was to find or to determine N, matrix N, the one that we are told that it's a 2 by 2 matrix. And now we need to find N. Let us check what is happening here between these two. We have got matrix M and we've got matrix N, and we are given its product, the product of these two. If we multiply M times N, we get this matrix of 4 minus 2, 0, 7. Yes, you can. Guys, this is mathematics. You can choose to say, let matrix N be equal to A, B, C, D, and so forth, which is fine. But let's get the idea of the question. What are they trying to say here? If I multiply M, this matrix here, and N, I'm supposed to get this value here. All right. So my question is simply that, how am I going to remove this M? In actual sense, if you're given like an equation, 2x is equal to 7. How do you find x? You're simply going to divide by 2 so that you find x. But under matrices, you don't divide. We're supposed to divide here by 2 to find n. We're supposed to divide by m. This side, we're supposed to divide by m. But under matrices, you do not divide like this. Like, yes, we are saying we are dividing, we are remaining with the n like this. But the concept is not like we are dividing a matrix and a matrix there. We are simply saying this is 1 over m that is multiplying our matrix 1 over m, 1 over m. And we know that 1 over m simply means m to the power of minus 1. M to the power of minus 1. So what does it mean? It simply means here I'm simply multiplying this matrix to the inverse of m, the matrix that I'm already having here, which is 4 minus 2, 0, 7. If I multiply this by the inverse of m, which is 1 over m, I'm obtaining n, because here I've cancelled m and m, but on this side, it's 1 over m, which is m to the power of minus 1, which is the inverse. That is what we simply say. Or like I said, you can choose let matrix N be A, B, C, D. It's a 2 by 2 matrix. You perform your calculations, you solve the equations and so forth. But here we can simply substitute because we have the inverse of M already. We calculated the inverse. That's why maths, it's a continuation. They know that you calculated this before. So use that as a continuation. So your inverse of M is going to be 1 over 4. So you're going to have 1 over 4 into 3, 2, 1, 2 multiplied to the matrix of 4, 0, minus 2, 7. So on this side, you are simply applying your proper multiplication of matrices, whereby we are using the row by column. By doing this, we are going to have matrix N. So we are going to apply our row by column concept. Just leave the 1 over 4 because this one, it's acting as a scalar. So we are going to start with this row and this column. So let's multiply 3 times 4, this was going to give us a 12 plus 2 times S0, which is S0 in this case. So this is a 12 here. So we are going to obtain 12 plus 0. We move on. We are done with this row and this column. We move on to the same row, but now on this column. So we are going to multiply on this column. That's 3 by negative 2, which is going to give us negative 6, 2 by 7, which is going to give us 14. We are done with this row and this column. Now we move on to this row versus the first column. So it's 1 times 4, which is 4, plus 2 times 0, which is a 0 in this case. We are done with this column. We are still on the same row, this row, but now it's multiplying this column. So it's going to be 1 times minus 2, which is minus 2 plus 2 times a 7 in this case, which is going to give us a 14. So this is what you're going to have. Knowing that we have the 1 over 4 that is still to multiply the answer that we are going to obtain after combining 12 plus 0 here, which is a 12, minus 6 plus 14 simply means 14 minus 6, which is going to give us 8. 4 plus 0, that's a 4. 14 minus 2, which is going to give us a 12. So from this part here, we can simply multiply each and every number inside by what? By the scalar, which is the 1 over 4. So the matrix N is going to be given as 1 over 4 times 12. So this is simply 1 over 4 times 12 over 1. So that's 4 into 12, which is 3. So here we're going to have 3. 1 over 4 times 8, which is the same way. 1 over 4 times 8, that is 2 here. So we are going to have 2. 1 over 4 times 4, that's 1. 1 over 4 times 12, which is going to give us a 3. So meaning to say our matrix N was going to be 1, 3, 2, 1, 3. So that is how we could have expressed our matrix N from this given information. So like I said, you can choose to let this matrix to be equal to A, B, C, D, and so forth, or you can just use this concept and inverse multiply to the other matrix that you're given. If you are given a product of two matrices, A times B is equal to C, to find B, B is equal to the inverse of A times C. If I want to find A is equal, the moment I divide by B is the inverse of B times C. That is the whole idea of our matrices. If we can understand this, we can attempt as much questions as we can on these matrices so that we have the basic understanding of what we are referring to. All right, on number 19, we are now given, in this case, that was in the triangle, in the diagram, we've got AB, this side's triangle, and another triangle 90, and the angle of 26,4. And we are asked using as much of the information, take note, using as much of the information given below as is necessary, meaning to say this information is supposed to be used as much as you can, this information that we see, the sign and so forth and so forth. All right, first question, calculate the area of triangle ABC. All right, so we need to calculate the area of triangle ABC. If we are to take note about this triangle ABC in this case, all right, that is our triangle ABC. It's a non-right angle triangle, but there's an angle that we are given there of 26,4, and the two sides here that we have. So you can use the area for a non-right angle triangle in this case, whereby we are saying area of triangle ABC is going to be half AB sine theta. So we can use half AB sine of theta in this case, whereby A and B are the sides creating our angle, the sides 8 and 12. So it's going to be half of 8 times 12 times the sine of theta, the sine of the angle that we are given of 26,4 degrees in this case. With this information that we have here, we can substitute, because we are given the sine of 26,4 on our information, the sine of 26,4, it's 0,44. So this one was the same as we are multiplying half of 8 times 12 times the whole sine of 26,4, which is the one that we are given as 0,44. That is the given information there. All right, so we can reduce this by 2. That is going to be 0 here by 2. That is going to be 2, 2. All right, so we are left with 8 times 12 in this case times this value, of which that is going to give us what? 8 by this, that is 16. We've got a remainder of 1. 8 by 1, that is plus 1, 96. 96 times 22, which is going to be 2, 1, 1, 2. Or many decimal places, we've got 2 decimal places in this case. So that is our area measured in square centimeters. So I just want you guys to multiply properly. Please do multiply properly and see if you're obtaining the same answer in this case. All right, then the other part was to calculate AD, the length of AD in this case. If you are to check here, we've got a right angled triangle now that we can consider here, where there is AD is on a right angled triangle. So here we can just apply Pythagoras theorem, since we have got two sides on a right angle triangle, and we understand that Pythagoras theorem says that h squared is equal to a squared plus b squared, whereby h is representing AD. So AD squared will be the square of these two sides. That will be 12 squared plus 5 squared. So that means AD squared is 12 times 12. Remember, that's 144. 5 squared, that is 25. 5 times 5. So AD squared is going to be, we add 5 and 4, that is going to be 9. 4 and 2, that is going to be 6. We remain with a 1. So in order for you to determine AD, this is AD squared, you're going to introduce the square root both sides. So that means AD was going to be the square root of 169, which is in this case was going to be 13. 13 times 13 is the one that gives us 169 in this case. So it's a matter of you knowing also your square roots, square root of numbers, square root of 144, the square root of 169, the square root of 64, the square root of 625. Once you know those ones, it's going to be easier now for you to simplify any square root of number that you be given in this case. So this. All right, moving on to question number 20, we are given that t is equal to 2 pi the square root of L over G. So on this part, the first question we're given or to determine or to find t when L given the information L, G, and pi. So this one was just a substitution that you are making into the formula for t, whereby we are given 2 times. You use the pi that you are given. The pi is 3,1. So it's going to be 3,1 times the square root of L over G. Our L was 156,8. Everything over 9,8 in this case. Or so meaning to say here we are going to obtain 2 times 1, which is 2. 2 times 3, which is 6. We're going to have 6,2 times the square root of, we can just simplify what is inside of our square root here, multiply by 10 over 10 to remove the 1 decimal place that we have. We are going to have 1,568 over 98. So if you were to reduce this properly digit by digit, you're going to obtain 16. That was going to give us the square root of 16. And for a square root, you can put the plus or minus, or you can just leave it like that. If you were to use the plus or minus, it was going to be plus or minus 4 in this case, which is the square root of 16. So you're going to write this as a plus or minus, or you can just write as 4. On the simplification part, it does not matter that you are using plus or minus or not. All right. So here we're going to multiply. T is going to be 4 times 2, which is 8. 4 times 6, which is 24 in this case. How many decimal places? We've got 1 decimal place. So meaning to say our T was going to be 24,8, or we could have our T as plus or minus 24,8. So on the simplification part, the plus or minus does not matter. But if you are to use it, then it's fine. All right, then the B part, we are asked here to make L the subject of the formula. Remember that before we are given that T is equal to 2 pi the square root of L over G in this case, and we want to make L the subject that is under the square root. The L that we want is under the square root. First things first, let us remove the 2 pi that is multiplying here, so you can just divide by this 2 pi. It's not affecting directly our square root, so we can just remove this so that we remain with the T over 2 pi, which is equal to the square root of L over G. So the question is, how are you going to remove the square root? You square both sides. So you're going to square here, and also you're going to square here to remove the square root. The moment you square both sides, you are getting rid of the square root. So that will be T squared. Everything is raised to the power of 2. 2 is also raised to the power of 2, which is going to be 4. Pi is also raised to the power of 2. So that will be pi squared, which is equal to the purpose of putting the square root. The square was for us to remove the square root. So the square root and the square cancels. You remain with L over G. So we want to make L the subject, remember. So you can cross multiply to remove our fractions, or we can just multiply by G both sides. We multiply this side by G. The moment you multiply by G here, you are remaining with L. Remember, what you want is to remain with L, whereby this G is same as G over 1. So you're going to multiply G times T squared, which is going to be GT squared over 1 times 4 pi squared. So this one was going to give us 4 pi squared in this case. So we have made L to be the subject of the formula in this case. So that was the whole idea of our question. All right, so that was 2 marks and 2 marks on this part, which is fine. Let us check the other part of question. That is, now we are given 21. Simplify giving your answer in base of 8. So these numbers, they are in base of 8. So you're asked to simplify number bases. So how do you deal with number bases? Same as you are dealing with the numbers, the concept of brackets, BODMAS, we are supposed to get rid of what is in the brackets first. So we are supposed to combine, in this case, what is in the brackets first. We're going to add 226 in base of 8 added to what? To 167 in base of 8. Remember your addition concept. You're going to add 6 plus 7, which is going to give us 13. 13 is bigger than the base. Remember, if the value is equal to the base or more than the base, you divide by the base. So you divide by 8, which is our base. So 8 into 13, that is going to be 1. Remainder what? 13 minus 8, which is going to give us a remainder of 5. So the remainder, this one, is the one that you're going to write on your final answer in base of what? In base of 8. So what is going to happen with this one? We are going to carry it to the next term. What that means, we are going to add 1 plus 2, which is 3, plus 6, which is 9. 9 is also more than the base, so you divide by the base. That is going to be 9 divided by the base. 8 into 9, that is 1, remainder 1. The remainder is the one that you write on your final answer. This one here, we are going to carry it to the next part. So meaning to say we're going to add 1 plus 2, which is 3, plus 1, which is 4. So 4 is less than 8. We can just write it as it is because it's less than 8. So this is the part that we are obtaining from our brackets. So we are going to subtract now 503 in base of 8 minus the part that we got from our brackets, which is 415 in base of 8. Remember your subtraction concept. 3 minus 5, it's impossible for us to subtract there. So what are you going to do? We are going to add the base. You add the base, so it's 3 plus 8, which is going to give us 11. Then we carry a 1, so we give a 1 here. We are going to give a 1. So if you give here a 1, this is going to be a 2. So you add the base, you give a 1. Add the base, give a 1, all right? So let's subtract 11 minus 5. This time we can subtract. This is going to give us 6. 6 is less than 8. So you can write our answer as it is. We are in base of what? 8. We move on to the next term. 0 minus 2, it's impossible. So we add the base. We are going to add the base. 0 plus 8, that's it, 8. We give 1 to the next term. So 4 plus 1 is going to give us a 5. Here we subtract 8 minus 2, which is going to give us 6. 5 minus 5, that's a 0. So we are going to obtain 6 in base of what? In base of 8. So that was our idea of this question. Let's check the second part of this question, which is logarithms. Evaluate the logarithm of 3 plus the logarithm of 9 over the logarithm of 405 minus the log of 5. Here we can first apply the laws of our logarithms like addition, because we are adding our logarithms, the logarithm of A plus the logarithm of B. Where was this one taken from? It was taken from the product of A and B under the same logarithm. We talk about the subtraction of logarithms, the logarithm of A minus the logarithm of B. It was taken from the division of numbers under the logarithm A and B. So meaning to say on top here, we are going to apply the law of addition. We are adding the base at the same, we are in base of 10. So we're going to multiply our numbers, that is 3 times 9 under the same log. Over, we divide. 405 is subtracting log 5. So we're going to divide the numbers under the log. 405 in base of 5. So that was going to be the condition. So there we can multiply our numbers. We're going to have the logarithm of 3 times 9, which is 27, over the logarithm of, we can divide here 5 into 5, that is 1, into 40, that is 8, into 5, that is 1. So we are going to obtain 81 in this case. Now I talked about the division of logarithms on a separate part. I said there are 2 ways that you can play around. You can change this, the logarithm of A over the logarithm of B. I say this is same as the logarithm of A in base of B. So here we are having 27 and 81. We can write this as the logarithm of 27 in the base of 81. You simplify this, or you can write these numbers in terms of the same base. That is the 27 and the 81 in terms of the same base. Which base can we use for 27 and 81? That is going to be the base of 3. 27, same as 3 to the exponent of 3. 81 is same as 3 to the exponent of 4. Why using this condition? Because we understand if a number is multiplying a logarithm, we can raise that number to be the exponent of the log. So if it is an exponent, therefore this number was multiplying the log before. The exponents that we see, they were multiplying our logarithms before. So this was 3 log 3, this was 4 log 3. So we can drop our exponents to have 3, the logarithm of 3 over, we drop the exponent for a logarithm of 3. Once you are at this stage, the idea there is that the logarithm are the same, the log 3 and the log 3. So these can be cancelled together, meaning to say you obtain 3 over 4 at the end. So the whole part of this logarithm was going to give us 3 over 4. If we were to calculate from this way, were we going to obtain the same answer? Yes. If we were to change this into log 27 base 81, we're going to say let the log of 27 in base 81 be equal to x. So that means we are going to convert this to exponential form. 27, our number is equal to the 81 to the exponent of the answer, which is x. Now we can solve this x from our exponents, our indices, making the basis to be the same. 27 is same as 3 to the exponent of 3. 81 is same as 3 to the exponent of 4, but there is x we are going to multiply. We know that the bases, if they are the same, we equate the exponents in this case, which is 3, will be equal to 4x. So if 3 is equal to 4x, we divide by 4 by 4, so x is going to be 3 over 4. So it means the whole logarithm of this part that we had is going to give us 3 over 4, which is the same answer as the one that we got here. So that was the condition there. 2 marks, 3 marks, all right? So that was a lot. So here, don't write a log, you just write the answer. You got 3 over 4. That is the answer that you just write. You don't indicate to say here I obtained log, just the answer there. So that is what we are supposed to have. Let us check this other question. We are given a quadratic graph. That's a quadratic function. Y is equal to x squared. So this is the graph of y is equal to x squared. Minus 2x minus 4, whereby we are given passing through the x-axis, in this case at the point in the x-axis here, that's 2, at this point that will be 2 comma, because this is 2 units, so this is 2 comma 2 comma 3 comma 4 comma 6 comma 8, this is at 1, so this is 1 comma 2 1 comma, and this is now 3, sorry, we are saying 2 comma 2 comma 4 comma 6 comma 8. Now we are at 3, so at this point here will be at 3, this one 3 comma 2 and so on up to 4, the same thing, minus 0 comma 2 0 comma 4 0 comma 6 0 comma 8 minus 1. So here we are at minus 1, here we are at minus 1 comma 2. So this here we said we are at 3 comma 2. So this is just analyzing our graph and see what is happening on our graph. So you said this one is at 3 comma 2 and this one is at minus 1 comma 2, where the graph is passing through the x-axis. And also you've got the turning point in between here, that's 1 2 3 4 5 here straight. So we have got the turning point here at minus at positive 1, x is 1 here, y is minus 5. So our turning point is at 1 minus 5. So these are some of the things that you're just supposed to analyze before you even attempt your question. All right, so the questions are on the next page, where we are given the diagram that we have is of the graph of y is equal to x squared minus 2x minus 4. On the diagram, draw the graph of y is equal to 10 minus 2x. On this diagram, we are supposed to draw the graph of y is equal to 10 minus 2x. How are we going to draw this graph? All right, so the idea that we are going to see here is that we are referring to a straight line. This is a straight line that we are talking about here. Y is equal to 10 minus 2x. So in order for you to draw a straight line, you need a table of values, the one that is going to give us the values of x corresponding to the values of y in this case. So I said 3 values are enough for you to draw a line. So you pick 3 values of x from the values of x that you have on your graph here, from minus 4 here up to positive 6. You can choose any 3 values of x that you want of your choice. So in this case, we can just choose maybe minus 5, whatever value that you want. Minus 2, I mean, you can choose minus 2. 0. There are two ways that you can, I'm gonna explain another one, -2, 0, and 2. Let's see what's gonna happen. If x is -2, we substitute here -2, that will be 10, -2 times -2, -2 times -2, that is going to be 4, that is gonna be a positive 4. So that's 10 plus 4, which is 14. When x is 0 here, that will be 10 minus 0, which is a 10. When x is a 2, that's going to be -2 times, which is -4. So 10 minus 4, which is 6. So it's going to be 2, 6. Or you can simply use the intercepts. That's the other way that you can actually apply working with the intercepts. Which intercepts? We are talking about being on the x-axis or being on the y-axis. So what we know is that for the x-intercept, y at that moment must be equal to 0. So it's a point that you are referring of x and y, where y is equal to 0. You find the value of x. So you substitute on your equation, y is equal to 0. So 0 is equal to 10 minus 2x. Transpose so that you can find x. Positive 2x is equal to 10 divided by 2 by 2. So x was going to be a 5. This represents our x value in the x-axis. Then we do the same for the y-intercept because we are dealing with the intercepts in this case. We are going to do the same thing to find what we refer to as the y-intercept. The y-intercept is on a condition where x is equal to 0. So when x is equal to 0, we form a point where we've got x and y, but we are saying at this point, x is equal to 0. So if x is equal to 0, we substitute where there is x, we substitute a 0 there. That's going to be 10 minus 0, which is going to be a 10. So using the intercepts, this one that we have, we just mark the points to say the first one, we say the x-intercept is at a condition where x is 5, y is 0. So you just mark the point where there is a 5 on your graph. So like here 5, 4 here, we're gonna calculate in between 4 and 6. So you need 5 boxes, 1, 2, 3, 4, 5, somewhere here. This is our point 5, 0. We mark our point. We move on to the y-intercept. In the y-axis, our point is at 0, 10. X is 0, y is 10. So you mark the point 0, 10 in the y-axis. So as you can see in the y-axis, 0, 10 is going to be here. That's x is, y is 10 when x is 0. That is, you join the points, you are done. If you were using a table, you are supposed to locate these points that we have here. We are supposed to locate our points. -2 versus 14. When x is -2, y is 14. 14, that will be, according to this scale, it's 5, 10, 15, meaning to say each box represents what? That is what you need to understand. Or 1 is represented by how many boxes? 2 boxes represent 1. So this will be 1, 2, after 2 boxes, 3, after 2 boxes, 4, after 2 boxes, 5. So meaning to say to obtain 14, we just need 1 box from 15 because we are saying each box is represented by 2 boxes represent 1. This is 1, 2, 3, 4, 5. So we are going direct at -2. -2 versus 14. Remember, that's our point. -2 versus 14. So we mark when x is -2, y is 14. So 14 is just going to be 2 boxes below 15. So you are going to mark your point here. You move on to this other point, 0 versus 10. 0 versus 10 is the one that we marked here. We move on to the other point, 2 versus 6. When x is 2, y is 6. So according to this scale, remember I said 2 boxes, they represent 1 in the y-axis. So this is 5. So 2 boxes here is going to represent 1, meaning to say we have got 2 versus 6 because this is 5. We're going to have 6 here. So we are going to join these points that we have. So as we can see, it's just one and the same thing. If we used the table of values or the double intercept, which is the use of intercepts, you are still going to have the same line in this case. So all we need in this case is to join our points. All right, so let us join our points in this case from our ruler. Just gonna need a ruler here. All right, so we are going to just join our points, and as you are joining, you are supposed to extend where these points are, not just to join to that point direct, no, just extend a little bit your line that you are going to draw in this case. So this line that we are going to have is the line of y is equal to 10 minus 2x. It is passing through these points, all of the points. So that is the graph of y is equal to 10 minus 2x. That's how you simply draw a line from the given points. All right. So that was the first part of our question, to draw the line or to draw the graph, which is of y is equal to 2x, 10 minus 2x. So this is it's a straight line graph. Remember the format of a straight line graph, y is equal to mx plus c, whereby we are dealing with what? With the highest exponent of x being a 1. The highest exponent of x there, that's a 1. That is to show that we are dealing with a linear function. All right. Then on item B, they are saying, use the graphs to estimate the solution of the equation x squared minus 2x minus 4. What is representing x squared? Remember, that was your quadratic graph. 10 minus 2x, this is the line that we are talking about, the one that we draw. So they are saying, where are these two intersecting? What are the solutions, the values of x? Where these two graphs meet, they are equal. So you go to the point of intersection of the graph. So you're going to need the point of what? Of intersection of the given graphs. They are equal. So where they intersect, at that point, these two graphs, they are going to be equal. So what are we trying to say is that where these two graphs where these two graphs meet, they meet at this point. It's an estimation that you're going to take. So you take the value of x to the x-axis. You do the same at this point here. At the other point there, this point, they meet here. So where they meet, drop your values, the value straight to the x-axis. So you state the value of x that you see there direct. You state the value of x that you see here. So this one was supposed to correspond somewhere to 3,7, something like that. So this was supposed to be 3,7. And on this other side also, it was going to be at minus 3,7. So meaning to say the values of x that we need in this case is going to be x is equal to minus 3,7 or x is equal to 3,7. So that is how you take the values where the two graphs intersect. All right. On the other part, we are given state the range of values for which this graph of x squared minus 2x minus 4 is less or equal to 14. What are they trying to say? If we check this part here, it represents the values of y. Y is equal. They are just saying state the values of x or the range of values of x where y is less than or equal to minus 14. Where the graph is less than or equal to minus 14. Where are we going to have this on our graph? So we need to know our graph. Where are we having 14? On our graph, we are having 14 at this point here. This is where y is 14. So what we're going to do is to draw the line of y is equal to 14, because they are saying y is, the whole function there represents y. So we are going to draw the line of y is equal to 14 direct. That is 2 boxes before what? 2 boxes, just 2 boxes before 15. Remember, I said 2 boxes represents 1 unit. All right, so you draw your line. This is the line of y is equal to 14, meaning to say at this point along this line, our values of y throughout, they are equal to 14. So which values are less than or equal to 14? That is from this point going down, all these values, they will be less than 14 according to y. But the question is not asking about it, it is asking about the range of values of x. Where is x affected? So you can see that x is affected at this point where the line meets with y straight to the x-axis. We get the value of x. Where this line and the graph of y meet straight to the x-axis with your ruler, you are going to obtain the value of x. So meaning to say, in between these values of x, in between, our y is going to be less than or equal to 14. But as x goes out of this range, y is going to increase. As x is going out of the range, y is going to increase. So when y is less than or equal, it's in between this interval within the values of x, starting from where? Down here at this point. So you take the point, it was supposed to be somewhere around minus 3,4, and here it was supposed to be somewhere at 5,4. So you are taking the values of x where the line and the graph intersects. So this one is a range of values. Now we are going to write it as an inequality to say our x is supposed to be greater than or equal to that value. of the first one was a negative 3, 4, or our x is supposed to be less than or equal to 5. If there is a less than or equal to, your inequality is supposed to carry less than or equal to also. So you're supposed to be very, very careful about that. So x is in within this interval. But let's check how they gave us. Also, they gave us the same way, you see. So if you are given this less than or equal, you are supposed to have it on this part. But if they said it's less than, then you are not going to put the equal to. If it was like this, x squared minus 2x minus 4 is less than 14, your solutions, you are not going to put this equal to. You are not going to put that. But once there's an equal to, your solutions also must have that equal to. That is the idea of these typical questions. All right, so that was it there. 5 marks, everything, 5 marks. All right, number 23, we are given in this case on the, all right, that's a diagram, and they're given, the diagram shows that the arc of a circle with the A, B, and in this case, construct the locus of points. All right, let's see our question. We are asked to construct the locus of points equidistant from A and B. Remember, from our locus of points equidistant from A and B means the line bisector. We are bisecting A and B in this case, where these two meet, all right, A and B. So we're going to bisect that line. How do you bisect a line? Remember, all you need is to just open more than half a line. So here at point A, we are going to open more than half of the line. We mark an arc where we expect our bisector to be, somewhere here. Another arc on the other side, we expect our bisector to be somewhere here. Without changing this distance, you move on to the point B. You do the same thing without changing this distance. At point B, we are going to mark back our arc. At this point, we are going to have our arc, and we also do the same thing on this side. We are going to have our arc like this. All right, so that is how you bisect a line from our construction and loci concept. I hope we are together on this part. So there, you're going to join the 2 points. That is where these 2 arcs meet. That is going to give us what? The bisector of the line. All right, just a little bit here like this. All right, so just draw even outside, because you do not know what's going to happen on this question, whatever that we have. Maybe it might affect what is outside of this. All right, then the other part of the question now is, let us take note. C is another point on the arc. So C is found on the arc such that BAC, such that from B to A to the point C, going to where C is, we are supposed to form 90 degrees, because it's supposed to be on the circle. We are supposed to form 90 degrees. That's what they are saying. All right. By construction, mark and label the point C. We are supposed to do this by construction. So which idea are we supposed to use that from B to A to C, we are supposed to form 90 degrees? Which idea are we supposed to use? Okay, this is the concept. This angle is a line bisector. It creates an angle of 90 degrees here. This is this angle that we see here, it's 90 degrees. So meaning to say, if we construct a line here to meet the circle at a certain point, whereby we are saying we are going to have 90 degrees, what does it mean? It automatically tells us that these 2 lines, they are parallel. It can't be that this angle is 90 and this angle is 90. It can only be that because they are co-interior angles, and you know that co-interior angles add up to 90. So in this case, they are simply saying construct a line parallel to this line. If it is parallel to this line, therefore the angle that is formed here is going to be 90 degrees. So how are you going to construct a parallel line? You simply measure the distance along this line, because it must be parallel to this line. So you measure from the center, which is the point, up to A, like this. This remember, parallel lines, what I said, they maintain the same distance throughout. Parallel lines, they maintain same distance throughout. So if they maintain same distance, you work with the distance from this point here to this point. That is where we have what? That is where we can tell the distance. So this distance that we see here must be maintained throughout this distance. If we check along the line, we must maintain the same distance. Meaning to say, you can just mark at any point, you construct using the same distance without changing the distance, because you understand that these 2 are supposed to be maintained throughout with the same distance. So with this arcs, you are going to join the backs of this arcs here to this point, all right, like this. So this arcs here joining to point A, you are going to see that the line that we are going to join here is going to be parallel to the other line that we had. These two lines, they will never meet, they will never meet. So meaning to say these two lines, they are parallel. And if they are parallel, it means this angle is 90, also this angle is 90. From which concept? We're talking about co-interior angles adding up to 90. So that was how you were supposed to attempt this question. All right, then the other item they are saying, write down the radius of the circle. How are you going to note or to tell the radius of the circle in this case? All right, there it was something else. You're supposed to understand your circle geometry now. You are supposed to know your circle geometry this time. From which concept? In this case, is because of this paper, actually, because of these adjustments. So I won't obtain the exact value. But the idea of this question was taken from here. How do you know the radius? You must be able to locate a diameter first. This one is not a diameter. You don't assume to say, this one is a diameter. No, no, no. There's no assumption in maths. You don't assume to say this line is passing through the center of the circle because it has bisected this line. What we can actually tell to say this is actually the diameter of the circle is from this concept here, from this point that we are referring as C, because we are saying this point at the circumference is C. And this angle formed here is 90 degrees. It's only a diameter from our circle geometry that creates or that forms an angle of 90 degrees at the circumference, meaning to say this angle that we see at 90 degrees, it cannot be formed inside. We cannot have a line like this forming an angle of 90 degrees at the circumference, and this line not being a diameter. It's impossible. It's only a diameter that subtends an angle of 90 degrees. So it means from C up to B, this line represents or indicates our diameter of the circle. So if this is our diameter, if BC is the diameter of the circle, by measuring from the actual measurement, this was going to give us 6.8 centimeters. Then we divide it by 2 now in order for us to obtain what? The radius, because we are saying this is our diameter. So the radius now was going to be diameter over 2. That is 6.8 over 2, which was going to give us 3.4 centimeters. So that was going to be the radius of the circle if we are using the proper measurements there. But because of these papers, you photocopy, you scan, you do this, so you won't having exact values. But from the one that we had with the proper dimensions, it was going to be a 3.4. All right, then on the other part, it's that is the transformation part, whereby we are given, all right, draw the image of triangle ABC under a reflection in the line x is equal to 2. All right, we want to draw a reflection of triangle ABC. Take note, this is our triangle ABC, the one that we are having here. That is our triangle ABC. So the question is for us to draw a reflection of this triangle ABC under a reflection in the line of x is equal to 2. How are we going to do that? We simply need the line of x is equal to 2. All right, so here we are going to use the reflection concept, the mirror line concept. Remember, I explained about the mirror line concept to say a mirror line, when you are referring to the points that are taken from the mirror line, what you can simply have or is the distance traveled or the distance that you move to the mirror line. This is our mirror line of x is equal to 2. That was our mirror line in this case. This line represents x is equal to 2. So the idea is that the points that we take from the object to the mirror line, the distance that you're going to move in the straight line is going to be the same. So here we are going to move from point A to the mirror line. How many units? That is according to scale. That is 2, 4, 6 up to this line. We move straight in this line 6 units to the other side. So we're going to move 2, 4, 6. So meaning to say we shall see the image of A1 6 units from the mirror line. B, according to scale, this is half a box and a complete box. So we are going to have half a box and a complete box somewhere there. So the complete box is going to appear somewhere here. So we've got one box and half of a box. So that is going to be our B1. Distance to the mirror line, distance to the image, the same as C, distance to the mirror line, same distance to the image. So our C1 was going to correspond somewhere there. Then you join your points in this case from point B1 to C1. We are just going to join these points. We do the same thing from the point B1 to the point C1 in this case. All right. So this one we can just join B to A1 like this. All right. Then the remaining part we can just combine these two. All right. So let us just combine and see what we are going to have at the end, something like this. All right. So there we're just going to join these points. So that is how you draw a reflection. Distance to the mirror line is same as the distance to the image. You mark your points, then from there you join them. Describe fully on the item B. We are being asked to describe fully the single transformation which maps triangle ABC onto triangle PQR. So we want to describe what is happening between these two triangles. This is our triangle PQR. So this is where we have our P, where we have our Q, and where we have our R. So let us just try to have it in a normal way so that we can properly see here. So it was like this. All right, then this line here is like this. So let us just have our clear diagram first here. All right. Okay, sorry for that. So let me just correct this part before we attempt our question. So this one, let us also join so that it can be clear. This is our triangle, so we can now properly see it. This is PQR. So our question was for us to describe the transformation which is mapping this triangle ABC onto this triangle. So the first thing was for us to check, as we can see here, we are expecting to be enlargement or to be a two-way stretch. These are the two transformations that can enlarge, that can make the object to be big from where it was. The isometries, remember, we talk of rotation, reflection, translation. So the three isometries are not there because this shape and this shape are not of same size. The size is bigger. Shear is not there because from the properties of a shear, I think I explained that the sides you'll be seeing that it will be slight. The shape won't be of the same properties. Here we are having this shape being of its same properties as it was before, but just it's being increased its size. So is the increase proportional? That is the question. If this side, this is our image here, which is PQ, it has got 2, according to the boxes that have been covered. Our code units is 2, 4, 6. We've got 6 here. Here we've got how many boxes covered? 3 boxes. 6 divided by 2, that's a 3. If we check this part here, 2 boxes are covered, 1 box is covered. So 2 divided by 1 is going to, so this part has been increased proportionally. So that is a enlargement. The sides were being increased in the same proportion. That's an enlargement. So how can you also prove that it's an enlargement? You join corresponding point. They must meet at the center of enlargement. The points that corresponds. The B here, that is at 90, and the Q, these are corresponding elements. If we are to join these, they must meet at the center of enlargement. If they do not meet, then that means it's a two-way stretch. Two-way stretch, these points, they are not even supposed to intersect. They do not even intersect. So you join corresponding elements, B to Q like this. All right, we do the same thing. As we can see here, R is corresponding with C, A is corresponding with what? With the Q. So R is corresponding to C. This one at the end of from B to C, from Q to R, these two, they do correspond. So we are going to join them, these two here So if they do not intersect, it's not an enlargement. Enlargement, they do intersect. A two-way stretch, these ones, they do not even intersect. That is to tell now, okay, this is not enlargement, this is a two-way stretch. But here, as we can see, these ones, they are joining each other. They are going to join. Is it that so? All right. So that's A here, our Q, our P a little bit here. So we are going to join from A to P as well. So by joining, as we can see, these points, all they meet at point -2, which becomes the center. So that means this truly is enlarged. Now we can conclude. Before we were having a confusion, is it enlargement or a two-way stretch? So you join, if they join at a certain point, that's an enlargement. So it is an enlargement. Now you are describing it is an enlargement in this case. The center of enlargement in this case being where these lines meet, they meet at what? At -2, 0. So you state the coordinates of that point. That's at -2, 0. X is -2, y is 0. What else do we need? We need the scale factor. We are going to need the scale factor. I explained on the transformation that the scale factor was supposed to be the distance that you're going to take from the center to the image, from the center to the object. But I said also, you can use corresponding sides, the ones that we're using here to say, this side is 6 units, this side is 3 units. But we have to check from A to B, we are going this side to the positive. From P to Q, we are going this side to the negative. So the question is, this direction is going to carry a negative. We are going this side is a negative. So our scale factor is going to be the corresponding image line, over the corresponding object line. What corresponds? The image P to Q is a -6 over from A to B. This corresponds from A to B, we are going to the positive. So we are going to obtain a scale factor of negative. If we want to use R to Q, we are going down in this case from R to Q. This one is going down. So it's -2 over from C to B, we are going up, which is +1. So that was going to give us a -2, which becomes our scale factor in this case. So scale factor, we can use the distance, that is the length of the image line to the length of the object line, but considering the direction where it is going. Is it going to the right, to the left? Is it going up or down? That affects our sign also. Number 25, we are given the diagram is a velocity time graph of a particle. Find the acceleration of the particle during the first 4 seconds. So as we can see, during the first 4 seconds here, it's a deceleration, meaning to say we are going to obtain a negative value, because as we can see, during the first 4 seconds, we are decreasing. There's a decrease, but the idea does not change. Remember, acceleration is simply the change in velocity over the change in time. That means we are simply having V2 minus V1 over T2 minus T1. So the change in velocity, our velocity, we started at 60. It decreased, now we are at 30. So this is our V1, this is our V2, which is corresponding at 30. So V2, that is 30 minus V1, which is at 60. Everything over the time that was taken from 0 to 4, that's 4 minus 0, which is a 4. So 30 minus 60, that was going to be minus 30 over 4. You can reduce here by 2, that's 2 by 2, that's -15. So at the end, we're going to obtain 2 into -15, that's -7.5 or -7.5, which is measured in meters per square second. We are dealing with acceleration, meters per square second in this case. All right, calculate in terms of h. Whatever that you're supposed to do is supposed to be in terms of h. The distance covered from t is equal to 4 up to t is equal to h. From t is equal to 4 here, they are saying from this one, from t is equal to 4 up to t is equal to h, the distance. Remember, distance, simply, we are talking about the area under the graph, all right? So this one, we are simply talking about the area under the graph. So the distance there, we are talking about this area, which is the area of a trapezium from 4 to h. So the area of a trapezium is given as what? You have sum of parallel sides times the perpendicular height in this case. So it's half sum of parallel sides times the perpendicular height. That is the sides that are parallel are these ones that will never meet. From this point up to this point, which is 30. From this point up to this point, which is 80. It corresponds on the height there on top, which is 80. All right. So, okay, let me change this one. All right. So that is going to be 80 there. So that we are considering this part and the whole of this line. This is our lines that are parallel. The perpendicular height is the difference between these points from 4 to h. That is going to be h minus what? 4. So meaning to say our formula was, if we are to substitute here, we're going to have our distance as half of sum of parallel sides. We add 30 and 80. So this was going to be 30 plus 80 times the perpendicular height, which is the difference from 4 up to h. It's h minus 4. So this one is going to be h minus 4. So that is our expression. We can just simplify further here because we're going to have 30 plus 80, which is 110. Then 2 into 11, that's going to be 5. Remember 1 into 10, that is 55. So we are going to have 55 into this bracket, or you can expand, or you can just leave it as 55 into h minus 4. So that was the expression of the distance from t is equal to 4 to t is equal to h. All right, we move on to the item 2. Now from h, t is equal to h up to t is equal to 25. Let's check what is happening from h up to 25. Again, an expression for distance, which is area. Now we want to consider area under this shape, which is a trapezium. Again, the whole of this shape is a trapezium. So you're gonna need half. This time, the sides that are parallel are these ones on top. The sides that will never meet, you're talking about these sides on top. So meaning to say we are referring from this point, which is at h, up to 21. So the length is going to be the difference 21 minus h. So here we are going to have 21 minus h. Then from h up to 25, we are going to have 25 minus this h. That is going to be the distance that we have from h up to 25 is going to be 25 minus h. And our height, the perpendicular height is 80. This 80 that corresponds to the height of 8 there. So this is what we're going to have. So meaning to say our formula, we're going to have our distance as half of the sides that are parallel. We said the sides that are parallel is 21 minus h plus 25 minus h. So we are going to have 21 minus h plus 25 minus h times the perpendicular height. Our perpendicular height is this one of 80. So we are going to multiply this to 80. That is our perpendicular height. It's 80. All right, so you can simplify further. In this case, half of 80 is going to give us a 40. So it's going to be 40 into, we simplify the brackets, 21 plus 25. That is going to be 46. So we're going to have 46 minus h minus h. This is same as minus 1h minus 1h. So we are going to obtain minus 2h. So this was the expression. If you want, you can expand your brackets, but that was the expression for the distance that we are given. All right. Then now they are saying on the item C, given that the distance covered from t is equal to 4 up to t is equal to 25, it's 1.395 kilometers. Find the value of h. They are saying the distance that was covered from t is equal to 4 up to t is equal to 25. Here from 4 up to 25, they are referring to this whole part here. Remember, as before, we calculated this distance that was here in terms of h. We calculated the distance of this part in terms of h. So they are saying that distance that we calculated before, if we combine it, we must get the numerical value of this distance that we are given. So in the first place, from t is equal to 4 up to t is equal to h, we got our distance as 55 into h minus 4. From t is equal to h, a continuation from where we left to 25, we got our distance there as 40 into 46 minus 2h. So this whole distance was covered from t is equal to 4 up to t is equal to 5, which is the same from t is equal to 4 up to t is equal to 25. But now we are given the numerical value, which is 1,3 95 in kilometers. Our distance is supposed to be in meters. So we multiply this by 1,000. So that is going to be 1,395 in meters. So we have an equation for the distance. With this equation, we can be able to solve for h by solving expanding of brackets, collecting in terms. We can calculate what is the value of h. You use the information that you are given to calculate whatever that you're asked there. So expand the brackets, we're going to have 55 times h, which is 55h minus 55 times 4. You're going to obtain 220, 40 times 46, 1,840. 40 times minus h, which is minus 80h, is equal to 1,395. So you can collect our like terms. There we've got h, and there we've got h. So it's 55 minus 80 is same as 80 minus 55, which is going to be minus 25h. Then if we collect these terms, minus 240, we add 1,400, and so it's going to be 1,480 minus 220. So this was going to give us 0,261. So we're going to obtain 1,620, which is equal to 1,395. So minus 25h was going to give us what? We transpose this, a negative to the other side. It's going to be a negative, a positive to the other side is going to be a negative 1620. So you're going to subtract 1620 from this value. So definitely, as you can see, this is a smaller value and this is a bigger value. So you subtract bigger value minus the smaller value. You get 225, and you multiply that by a negative because we are subtracting smaller from what? The bigger value. So to find h, simply divide by negative 25 both sides. So h is going to give us what? That's a positive 25 into 225. That's going to be a 9 in this case. So h is going to be equivalent to 9. That was the whole idea of this question. And let's check the other part. We have got probability. All right. Let's see our probability here. In a shooting game, Nyarai is allowed 2 shots. The probability that she hits the target first time is 0.7. So here the probability for her to hit the target is 0.7. What about the probability that she's going to fail to hit the target? Remember, probability of the everything to hit the target and failing to hit the target, it must add up to 1. So we are simply going to subtract 1 minus 0.7. We find what is remaining, which is going to be what? 0.3. So meaning to say for her to fail to hit the target, it's 0.3. All right. If she hits the target, we are focusing on hitting the target. Take note. If she hits the target, now, the probability that she hits the target the second now, if she hits this target, this is the first one, she hits the target again, we are given that the probability there is going to be what? Is going to be 0.6. So the probability here is going to be 0.6, or otherwise. What is the otherwise mean? The otherwise means if she fails to hit the target, then she hits the target the second time, then the probability of hitting this target the second, like on a second chance, but while she failed the first time, that one is going to be 0.3. That is the otherwise that we are given there. So the question is complete the probability, the tree diagram below to represent all this information. So already, as we can take from this information, we now know that this is 0.3. This one we are given, but I said the probability of happening and not happening of an event gives us a 1. So if we understand that, we are simply going to say this part must give us a 1. So we subtract 1 minus 0.6, which is going to give us 0.4. The probability of this part happening and not happening should give us a 1. So it's 1 minus 0.3, which is going to give us what? 0.7. That's how you answer a probability diagram. To fill in the probability must add up to 1. All right, now they're saying, calculate the probability that she hits the target twice. She hits the target twice. That means she hits for the first time, she hits for the second time. That is to hit twice. That is the only condition, because for the first time here, she has failed to hit. So she can't, yes, she can hit the second time, but it's not twice because she failed in the first place. This one is a fail and this one is a fail. So it's impossible. This one here, it's a hit followed by failing to hit. So this part does not work. So we are going to take this part of hitting the first time and also hitting the second time. So what is the probability? We just have to multiply 0.7 times 0.6. So what are you going to obtain? 7 times 6, that is 42, right? 42 there. So sorry for that. Right, sorry for that. So this one is going to be twice. That is when she hits the target twice. The first one is a hit, the second one is a hit. So you're going to multiply 0.7 times 0.6. So there you simply multiply 7 times 6, which is going to be 42. How many decimal places that you consider? 1, 2. So you're going to have 1, 2. That would be 0.42 in this case. All right. Then the other question is calculate the probability that she hits the target once. In this case, that is only once. So it means she can hit the target, fails to hit the target, or she can fail to hit the target, then hits the target. So which conditions are we going to work with? We are going to work with this condition. She hits the target the first time, she fails for the second time, or she fails for the first time, then she hits for the second time. These are the conditions that she hits the target only once. Only once. So meaning to say we're going to combine the first one, 0.7 times 0.4, this one, plus this one from 0.3 and 0.3. So that was the idea of our question. We multiply, combine our terms together. 7 times 4, that will be 28. So 2 decimal places, 0.28 plus 3 times 3, which is 9. 2 decimal places, so it's going to be 0.09. Then we add this, we are going to obtain 0.37. So that was going to be the probability of here hitting once. So as you can see, this was a nice question paper, but it was a lot. All you just need, guys, is to revise as much as we can. And that can actually help us to reach our goal as much as we can. Let's continue to revise our exams. They are around the corner. So we just need to work on more question papers. Let us know the questions to work on, the papers to work on, so that we can revise those papers together on this platform at Maths on African Motives. But for now, that's it, guys, till we meet again.